Hello, Blurry Cat. What is my microphone? Yes, it is indeed a SM7B. If you're looking for a suggestion on what microphone to get, this is a very good microphone. Absolutely zero complaints. It used to be in the past that you had to use it with some special hardware in order to get enough gain and like enough volume. Um, but modern interfaces don't require you to do that anymore. Like if you look at old stuff, the people would tell you that you needed a uh actually for I even forgot the name of those devices. Something was called something cloud. Yeah, one is the cloud lifter. Yes, the cloud lifter. The other one I forgot the name of. But in any case, I have a cloud lifter and I don't use it anymore. Um so you no, it's not phantom power. It's something that consumes phantom power. This guy doesn't need phantom power, but those devices like the cloud lifter consumes phantom power in order to give you. They're basically amplifiers, but they're like tiny, dedicated, meant to not introduce uh, noise. In any case, you don't need those anymore. So if you have a good interface, for example, if you have any of the Rode hardware, my recommendation is to use the Rode hardware um, to power it. That being said, I have no experience. I have no personal direct experience with it, but I have, generally speaking, a positive impression of the new version of this one, the MV1, I think it's called, where it even has like you can even connect it via USB. So I think that is very similar uh, and it should be good. So so what I would say is, unless you, I don't know, I personally would go for the newer one than this one if I had to start from scratch. But if you like if you dig this look, like if you really want an SM7B, go for it. Get a decent interface. I would recommend the Rode interface, honestly. Don't go for the Scarlett. Don't go for like there's a bunch of mid ones. Just avoid them. That being said, I have no much experience. I don't have much experience with Rode on Linux. I've been using Rode on Windows and Mac. Um, Togglebit uses, I think, Togglebit has a Rodecaster. At least he used to, and he uses it on Linux, and I think he's fine. I mean, ultimately, it's mostly like, yeah, there's the customization software, but then you can customize the thing by clicking on it. Like, so long story short, I think you should be fine either way. Another marathon stream today? I don't know. We'll see. I need to switch to an XLR microphone in both a USB 80-2020 before. Oh, I see. um, yeah, by the way, I said Rode because that's what I use and it works well for me. Obviously, this is not the only brand that you should trust. There's more than that. I used to have a Scarlett. Didn't I it was fine, but I don't love it. Uh, yeah, in general they have no problems. Although I think with the Scarlett, for example, it would start like popping after a while, like some kind of like buffer timing math not working out, and like at some point it would like it would start like I don't know, like there wasn't enough buffer and it would start consuming at the very end and like crackling whenever it hit the very end of the buffer. You know what? That's also my assumption. I don't know for sure if that's exactly what was happening. In any case, like unplugging and replugging it would fix it. But it wasn't like an experience that you would love. So yeah. Okay, this one is green, so we're also merging this one. Yeah, that was on Windows, by the way, not on Linux. So you know what? Maybe it was Windows' fault. I don't know, man. Anyway, what are we doing today? So I wrote it here. The plan for today is to experiment a little bit with ZSTD and then to look into client persistence, to finish client persistence. So I made a lot of progress with client persistence. So if you look here at my code, here's what I did. I changed host sync. Now host sync. Also, the fact that I made this a sub object, like a substruct, that's probably a silly idea that makes no sense. I'm gonna flatten this. In any case, for now, here's the idea. There's this host delta thing. The idea is that previously host sync contained a full copy of the host, but now we want the host delta. I mean, we could have provided a partial, like even though the type is host, we could have contained partial information, but this one is more this is right for what we're going for right now. So the most important thing is that it contains information of whether on the sync mode. The idea is, okay, you're reconnecting. The client also, by the way, authenticate protocol client. Authenticate now has the client tell us the max sequence ID that they have observed. So like the latest event that they observed. And so with that information, then the server can decide what to send. So for example, let's say that you observed the latest event that you observed had ID 20. Okay, so now look at users, and I noticed that most users have not been updated past ID 20, but one is. So what I will do is that I will put in here only the one user that has had changes, like they changed their name, I don't know, stuff like that, past 20, because user has a field. I don't know if we see it here. Yeah, I'm not putting this stuff in the object at this moment, but if you look at the table, I need to resync models and tables. If you look at the table, a user has a update UID. So we look at the update UID and we say, okay, this guy updated. So this client has not observed this user changing their name. So we're going to send down only this user. But there might be reasons. I have to formalize them. Like if you look at the markdown document that I have in the repo, I try to explain what the reasoning is. Although I need to actually make it, I need to implement it for real to see if my like general hunch is how well they work. But the idea is sync mode can be either delta or full, where the idea is normally you would want to receive a delta, but occasionally you might receive a full resync. For example, in the event that a user was deleted, for example, or if for any reason we basically, the idea is to resync everything and not just resync a delta. So if a user is missing in a full resync, it's because that user doesn't exist anymore. That's the idea. And yeah, so that's what I have. So I've like started the work to set this up, but I have not wired everything in yet. There's a function that it's in here actually, I think, that I stopped, but I haven't implemented, which is, oh, it is not in here. Let me think. Oh, right, because it's in host. Host has, drum roll, has compute delta. So for a given, this is a server only function. So the server for its current host, given a user ID and a max sequence ID observed, will compute the delta. And for now, the way we're doing it is just to keep it working. This is local stuff that I haven't committed, but just to keep it working, we're saying that the mode is delta, but then we send down all users all the time. What we need to do next to make this better is filter out based on the UID. And if we want to implement secret channels, then we need to filter channels also based on whether the user can or cannot see that channel. So yeah, put out on a 15 stream streak. Holy shit. Wow. Plus 450 bugs. Nice. Um so this is where we're at. The goal is obviously to make this better and start implementing all the sync stuff. I think I realized that some of how I envision synchronization to work probably will not be able to work exactly the way I thought, but I don't know. We'll see once we get there. As for experimenting with ZSTD, so here's the idea. Well, we're sending a bunch of data. This server is sending around a bunch of textual data. This textual data is obviously horribly inefficient. Like chat messages can be compressed a ton. So the idea is, well, to have some compression going on. And there are some nuanced techniques. There are some nuanced ways in which we can use compression. So, for example, once trivially silly way of compressing would be that we take our TCP writer, we wrap it in a compressing writer, and so whenever you write bytes to basically the stuff that you want to write on the network on the wire goes through the compressor first, and then on the other side, whenever you wrap the TCP reader in a decompressing reader and you decompress on the other end, that works. But nothing can stop us from instead applying compression at a more granular level, potentially even using different strategies. And what is particularly interesting about ZSTD is that it has this, which I want to play around with a little bit. Dictionary-based small data compression. I'll leave you this. I'm gonna move for a moment, just doing one thing. I'll be right back, and then I think I'm gonna start working on ZSTD. So I want to make a tiny CLI, a tiny application to try it out and see, for example, how much training data does it need, how much does the dictionary weight for small data compression, that kind of stuff. In any case, I'll be right back. Okay, I'm back. The sync can be quite big now. Uh, Let me read the rest first. If I'm there when the server is relatively new, don't use it for a year, then come back, the server would send quite a bit of data. That is not 100% correct because with how we're modeling it currently, clients do not have a full sync of the chat. Similar to Discord. Like when you open Discord, it doesn't take it long to resync with a server because it doesn't store all the message history locally. It only keeps around newest messages. We're structuring these under the same assumption. We're structuring a Awebo under the same assumption. The idea is that on a Awebo server can be big enough for it to have um, a bunch of activity that you don't really participate to, and it should still work fine. Kind of like some Discord servers are. No, I mean, I don't worry. I've been telling people. I've been like, if you were not here while I was saying this, then there you had no way of knowing. But it can be a bunch of information. So the way it works currently is your resync will send you 64 messages. This can be fine tuned, but for now it's 64 messages per channel. So if you're in a server with a lot of channels, you will receive a lot of messages for sure. It's nowhere near as bad as it would be, right? If it did a full sync. Like if we wanted to do full state sync, we would have necessarily to split it up into multiple into separate communications. Or in any case, there would have to be a way for this information to come in like streaming. Okay. So I want to play around with this just a little bit. Not the CLI. CLI sucks. I want to see the programmable interface. So I think we're gonna take a string, maybe a text message. We're gonna try to compress it. Um, you know what? Maybe just turning on the SED in Awebo as I described it originally, like just a reader and a writer implementation, and just calling it a day. Maybe that is the move. But playing around with the dictionary, like the dictionary seems interesting. In general, I believe I have these like I have this impression that dictionary compression should work particularly well for something like a chat application. Um, you just need to make sure to, well, train it reasonably well and periodically retrain it in order to fine tune the dictionary. And like just not have like one original dictionary and then just keep that around all the time. So maybe I don't know, like you retrain once every, I don't know, 24 hours, every hour, once a week, something like this. It has better streaming compression ratios than ZSCD in my experience. I know that broadly exists, and I know that it is used. I was briefly looking at some benchmarks, and they were showing ZSCD doing better than broadly. Um, that being said, so I wouldn't exclude it, but here's currently what's driving my interest. One is the dictionary compression. Um, Two is this. We have ZSCD packaged for Zig already in all your code base. Techatrix. Thank you, Techatrix. Techatrix has packaged it, so why not? Mm-mm-mm-mm. As for your first question, like what is more important? Well, the idea is that we're compressing this data in flight, so not at rest. So we want that compression to be efficient, fast. So if we're using ZSCD, we're definitely not cranking it up to the max. I was also looking at, this is funny, I was also looking at Lizard LZ5. This was funny because, Lizard, appropriate name for a Zig project, I guess. Where basically they were aiming to be something in between LZ4 and ZSCD. That's where they say it. Back in 2017, so this is an older project. Lizard 1.0 filled a niche between LZ4 and ZSCD in terms of compression ratio, as well as compression and decompression speeds. However, based on benchmarks conducted in 2025, shared below, both LZ4 and ZSCD have made substantial advancements, particularly in compression and decompression speeds, leaving Lizard outdated and effectively obsolete. Which is unfortunate, but in any case, so they have LZ4, I guess, being fast. So 579 megabytes, 3700 megabytes, compression ratio of almost 50%. And then these are like, this is better compression for in exchange for lower speeds, although it's not significantly better compression. Like you're like nuking, like here in the very last one, you're nuking your compression speed by a lot. The compression doesn't take much of a hit. So this is good, but you're nuking your compression speed by a ton, and you went from 47 to 36. Like you gained 10% ish, 11% ish. Yeah. Let's ignore Lizard since they're saying the Lizard doesn't do too well. There's ZSCD with the fast flag. ZSCD with the fast flag, as fast as LZ4, kind of comparable. I guess LZ4 here seemed to be better slightly at the very top. 579, 47, 573, 48. But I mean, you're there. And then you can take relatively small hits to pull down the compression ratio. Then there's normal ZSTD, non-fast ZSTD. Slower, yeah. But it's already, so this guy here is trading 100 megabytes, well, 150 megabytes per second of compression speeds, and it's already at 34. The compression speed, though, is slower, but I think of these two quantities, probably this one is for us is the most sensitive. Although, you know what? I guess we would want clients to compress as well. So never mind. At the end of the day, it's symmetrical. Like the compression cost is paid by the server and the client, because the client will want to compress when sending to the server, and vice versa. So I don't know. ZSTD seems interesting. Zlib, not doing great. Broadly. So Broadly is not super fast. Holy shit, definitely not fast at decompressing. Broadly seems much worse at decompressing than all the other like comparable ones. So again, according to, this is just one benchmark, but in this benchmark, Broadly seems brutal. So in a sense, the most lightweight one seems to be LZ4. Honestly, looking at all this stuff, I think this one is the best one for us. Is still LZ4. It seems even better than ZSTD. That being said, this does not contain the STD dictionary, because the STD dictionary, I guess it's cheating in a sense. Like, the dictionary approach is um it's probably much better, but it has to be fine tuned to the kind of stuff that you're sending around. Okay. I don't know. Let's see. Where's LZ4? Please no C++. Oh, ooh, it's C. Good. Do they have their own the comparison against the standard? Mem copy. Oh, they're going above one with factor. God damn it, man. Go below one, motherfucker. I hate this. So this should be what, 50%? I guess this should be one over, right? So this is like one half. 780. So this is a different machine, obviously. Baseline is this. To do. But yes, the fast compression should be quite a bit better. Z standard. This does not have Z standard with the fast option. So here they're comparing. Yeah, they should put Z. Is there like a better benchmark? Like, this fucking table is minuscule. Come on, guys, you can do better. Like, you're a serious project. Just like, why is this packaging thing more impressive than the benchmark thingy? Eh. LZ4 is also compatible with dictionary compression, both at API and CLI levels. It can ingest any input by its dictionary, though only the final 64 kilobytes are used. This capability can be combined with the Z standard dictionary builder in order to drastically improve compression performance on small files. I think the table only has fast. This should not be fast, or rather, because you can give. This is the standard with this is the standard with the easiest compression thingy, but it's not the fast flag. There's also the fast flag. Okay, this website is ass. Where's their like, for example, here you see here they separate them. This is the lizard compression thing. They separate the SCD, and the fast flag is different than just giving it -1. Is the purpose of compression just to reduce size and decrease network downloading time? No. It is one of the goals, yes. If you have a big sink, it's nicer if you get it faster. But most importantly, um, since this is going to be self-hosted, so you or one of your friends has to deploy the server somewhere, they will be subject to bandwidth limitations or to bandwidth cost. So compression is in order to straight up reduce your bill. Also, a server will have at the same time chat going on, and also potentially audio and video streams, and it will have a limited bandwidth. Probably, if you get a decent server, it will have like a gigabit connection at the very least. But you can start getting to you can start hitting some limits. So you don't want your like screen share to stutter because you're sending uncompressed chat messages at the same time. Like it would be hilarious that you're streaming and then whenever somebody sends a message, your your video drops a packet. So that's kind of the idea. It's general efficiency. Okay. Okay. Another argument in favor of not using ZSCD. I will start with ZSCD because that's what we already have packaged. But another argument in favor of not using ZSCD. Does ZSCD have a weird license? Do they have like the crappy you can't sue Facebook license? No, it just has BSD. Okay, never mind. So it's BSD, so it's fine. Facebook has, I don't know if they still do it, but they used to have like a weird clause to their open source projects where they were saying that you couldn't initiate litigation against them if you wanted to be able to keep using the like React. Actually, I'm curious. Do they still have it? No. This seems to be just MIT. Is there any other license file? They were asked to change it, right? Okay, I did not hallucinate this story. I know that it was sure. Uh, uh, Facebook React license change. Shouldn't Awebo dog food a pure Z compression library? You want to write that one? I mean, I'm on board for getting rid of C dependencies, but I don't know. The compression seems to be the one thing where you just want to use effort that other people have put. Is there nothing in the STD? Oh, you mean like full STD, full implementations in the STD? I think for the standard we have the compression, but we don't have compression. I think for a few of them we have like only one side of the thing. Yeah, from a contentious BSD plus patents license to the standard MIT license in September 2017. Compression was added back recently. Oh, you mean ZSTD? The Apache Foundation bans React. Yes. Hmm. Ah, there we go. Facebook says the BSD plus patents license is to protect them from meritless patent litigation. So they could do it without needing lawyers to sign off their changes. Oh. Hmm. Okay, you know what? I never looked into it deeply. I just remember hearing rumors about this stuff. I guess the rumors that I had were not exactly precise. I thought that they were talking about something more bespoke than BSD plus patents. Yeah. Anyway, mm, there's decompress, and that's it. This is unstable master. So I think we only have decompression. Under compress we have, let's see. Plate, LZMA, LZMA2, XZ. What's the relationship between LZMA and decode, decompress, range decoder, Flate, compress, container, decompress? So Flate has compression and decompression. XZ, just decompress. LZMA, there's an accum buffer, an accumulating buffer for LZ sequences, but okay, I don't know. LZMA has decompressor range decoder. Okay, so no, I think there's no compression. I think we only have compression for one of these bad boys. Is SDD the new hot meta compression one? I guess. Yeah. It's from Facebook, yes. Hmm. Okay. Let's take a look at man, this project is huge. bzip3. ZSD.h. Let's go 235446. What? Dependencies std-def, zstd errors, limits.h, static linking only. Wait, if static linking only and not static. Okay, whatever. Limits. C++ XMC. The SED visible visibility. Control library symbols visibility. Whatever. Introduction. Levers greater than 20 are labeled ultra. Should be used with caution as they require more memory. Library also offers negative compression levels, which extend the range of speed versus radio references. The lower the level, the faster the speed at the cost of compression. Compression can be done in a single step, described as simple API, a single step reusing a context, described as explicit context, unbounded multiple steps, described as streaming compression. The compression ratio achievable on small data can be highly improved by using a dictionary. Dictionary compression can be performed in a single step, described as simple dictionary API, a single step resulting a dictionary, described as bulk processing dictionary API. I'm not sure I understand fully the distinction between these two things. Well, I guess the simple dictionary API is you do it all at once. Like, here's my files, and the thing will automatically, or like, here's my slices, my buffers, whatever, and the thing will automatically first build a dictionary and then give you the compressed output. While in this case, it's first you make a dictionary, and then once you have the dictionary, you do compression of files that you provide or like data that you provide, and then you pass in the dictionary that you made first. Also, this does not do streaming, it seems. Advanced experimental functions can be accessed using ZSD static linking only before including ZSD. Why? Why? Oh, because advanced experimental APIs should never be used with a dynamically linked library. There we go. They're not stable. Their definition signatures may change in the future. Only static linking is allowed. I mean, fair. 160. ZSD version number. Oh, here's the magic number. It's the version major times 100 times 100 plus the minor times 100. Okay. So according to this, version 010 would be would result to number 100, not 1000. So they're leaving 2 digits per triplet. So they don't expect to go past minor or release version 99. Okay. Mm-mm-mm-mm. Oh, these signatures are delightful. ZSD all caps underscore camel case. Okay. Okay. Constance ZSD magic number. There's a Facebook in it. Magic dictionary. Magic skippable mask. Block size max. Simple core API. ZSD compress. Compress source content as a single ZSD compress frame into an already allocated destination. Note, providing destination capacity greater or equal than the ZSD compress bound guarantees the ZSD will have enough space to successfully compress the data. Return compress size written into the ST, which is going to be lower than the ST capacity. Wait, where's this backtick? Doesn't close. Oh no. Or an error code if it fails, which can be tested using ZSD is error. ZSD, but you do is error on this guy. ZSD decompress, I guess, is the other way around. We're not going to use this stuff, so I'm not going to spend too much time learning it. Decompression helper functions. The return value is not compatible with ZSD is error. God damn it. The compressed size field is optional, blah, blah, blah. ZSD deprecated. Replaced by get frame content size. Fine frame. Compress size, compression helper functions. Okay. Error helper functions is error. Get error code. Tells if size C function result in an error code. Hello, Fathon. Get error code. Convert a result into an error code which can be compared to an error enum list. Get error name. Mean C level. Max C level. Default C level. Explicit context. Let's see. Compression context. When compressing many frames, it is recommended to allocate a compression context just once and reuse it for each successive compression operation. This will make the workload easier for system's memory. Note, reusing context is just a speed resource optimization, doesn't change the compression ratio, which remains identical. For parallel execution in multi-threaded environments, use one different context per thread. Okay. Same as ZSD compress using an explicit ZSD CCTX. Okay. In order to mirror ZSD compress behavior, this function compresses at the requested compression level, ignoring any other advanced parameter. If any advanced parameter was set using the advanced API, they will all be reset. Only compression level remains. Okay, decompression context. Advanced compression API. API design. Parameters are pushed one by one into an existing context using ZSD CCTX set star functions. Push parameters are sticky. What? They are valid for the next compressed frame and any subsequent frame. Sticky parameters are applicable to ZSD compress 2 and compress stream. They do not apply to one-shot variants such as ZSD compress CCTX. Okay. It's possible to reset all parameters to default using this function. This API supersedes all other advanced API entry points in the experimental section. In the future, we expect to remove API entry points from experimental which are redundant with this API. Okay, compression strategies listed from fastest to strongest. ZSD fast, D fast, greedy, lazy, lazy 2, BT lazy, BT opt, BT ultra, BT ultra 2. Note, new strategies might be added in the future, only the order is guaranteed. Compression parameter, window length, hash log, chain log, search log, min match, target length, strategy. Okay. Get bounds. Set parameter. Set pledged source size. What? Total input data size to be compressed as a single frame. Value will be written in the frame header unless if explicitly forbidden using C content size flag. This value will also be controlled at the end of the frame and trigger an error if it is not respected. Okay. So this is like a safety check that you put in how many bytes you said you would, and you get out as many bytes as you expect, something like that. I don't know. CCTX reset, compress 2, advanced decompression API. Parameters are sticky. Okay. Streaming. In buffer, out buffer, start of the input buffer, size of the input buffer, position where the reading stopped will be updated necessarily. 0 pause size. Streaming compression, how to. A ZSD compression stream object is required to track streaming operation. Use create CStream and free CStream to create release resources. CStream objects can be reused multiple times on consecutive compression operations. It is recommended to reuse CStream since it will play nicer with systems memory by reutilizing already allocated memory. For parallel execution, 1 per thread. Yes. Note, since version 1.3, ZSD CStream and ZSD CCTX are the same thing. Oh. Parameters are sticky. When starting a new compression of the same context, we'll use the same. This description of parameters are sticky. Oh man. I didn't know that C variables could be sticky, but apparently they can. Reset. Okay, yeah, you set parameters. Fine. Use the ZSD compress stream 2 with ZSD eContinue as many times as necessary to consume the input stream. The function will automatically update both position fields within input and output. Note that the function may not consume the entire input, for example, because an output buffer is already full, in which case input position lower than input size, the caller must check if input has been entirely consumed. If not, the caller must make some room to receive more compressed data and then present again remaining input data. Okay. The SED continue is guaranteed to make some forward progress when called, but doesn't guarantee maximal forward progress. Yeah. Okay. At any moment, it's possible to flush whatever data might remain stuck within the internal buffer using SED compressed stream 2 with ZSTD flush. Output position will be updated. Note that if output size is too small, a single invocation of flush might not be enough. Return code greater than 0. In which case, make some room to receive more compressed data and call again that function with flush. You must continue calling it with flush until it returns 0, at which point you can change the operation. Note, flush will flush as much output as possible, meaning when compressing with multiple threads, will block until the flush is complete or the output buffer is full. 0 if internal buffers are entirely flushed. Greater than 0 if some data still present within internal buffers. The value is minimal estimation of remaining size on or an error code, which can be tested using ZSTD is error. I really wonder how the heck they're stuffing errors into this thing. Like, how does it work? I guess they're using big numbers to represent errors, like numbers with the highest bit set to 1, I guess. Calling ZSTD compress stream 2 with ZSTD end instructs to finish a frame. It will perform a flush and write frame epilogue. The epilogue is required for decoders to consider a frame completed. Flash operation is the same and follows the same rules as calling compress to with flash. Okay, so you need to keep calling it with en until it returns 0. Okay, man, this thing is. I was thinking what it would take to make a reader and a writer for it, and there's probably some stuff that you have to do, like some work that you have to do between the complexity of this thing and the complexity of the Zig reader writer interface. Oof. Okay, behave. Let's see. Compress stream 2 behaves about the same as compress stream with additional control on the end directive. Um, right. Continue, flash, and okay. System in size, system out size. Wait, these buffer sizes are softly recommended. They're not required. The SSD compressed stream happily accepts any buffer size for both input and output. Respecting the recommended size just makes it easier for the SSD compressed stream, reducing the amount of memory shuffling and buffering, resulting in minor performance savings. Why are those functions? Why are those fucking functions and not like comp time constants? Now, these recommendations are from the perspective of a C caller program. If the streaming interface is invoked from some other language, especially managed ones such as Java and Go, through a foreign function interface such as GNI, JNI, or SIGO, a major performance rule is to reduce crossing such interface to an absolute minimum. So you want bigger buffers then. That's what the thing is saying. It's not rare that performance ends up being spent more into the interface rather than compression itself, in which cases prefer using large buffers, as large as practical for both input and output to reduce the number of round trips. The following is a legacy streaming API available since version 1, which is replaced redundant but remains fully supported. Okay, so we skip it. Streaming decompression. How to? You need a decompression stream. Create 3. You init it. Recommended first input size. Alternatively, returns recommended first input size. Alternatively, use advanced API to set specific properties. Use it repeatedly to consume your input. The function will update both position fields. If input position lower than input size, some input has not been consumed. It's up to the caller to present again the remaining data. Okay. The function tries to flush all data decoded immediately, respecting output buffer size. If output position is lower than output size, the decoder has flushed everything it could. Yes. However, when the lengths are equal, it's more difficult to know. Right. You don't know if it happened to fit perfectly, if the data happened to fit perfectly, or if it just couldn't push any more out because because the space has been consumed. So if return greater than 0, the frame is not complete, meaning that either there is some data left to flush within internal buffers, or there is input to read to complete the frame, or both. Yeah. In which case you need to call again. With no additional input provided, amount of data flush is necessarily lower or equal to ZSD block size max. Okay. I think I finally get async in Zig. Nice. If you have questions or you want to double check your understanding about something, feel free to message. If a function is io.async, then you tell Zig the order of execution does not matter. This allows Zig to either run them concurrently or sequentially. Yes. If you want to ensure concurrency, then you have to use io.concurrent. Yes. You have to try to catch them because IO can be single-threaded. Not only that, you can just straight up round out of threads. Like there's a limited amount of threads that you can create. Maybe both because there could be limits enforced by your system, and also because you could be running out of system resources. Like at some point, your OS might not be able to dish out any more threads. If you're doing green threads instead, you might run out of memory. Green threads don't consume OS resources the same way that OS threads do, but they will consume memory, and your process might run out of memory. And this can both be because you're literally running out of memory, like your RAM sticks don't have any more free bits to give out, or you are hitting some kind of soft limit. For example, it would make sense for an application to have a soft limit on the number of OS threads that it wants to spin up at maximum. Like this is a setting that you can specify in io.threaded. When you create an io.threaded, you can say this is going to be the maximum thread pool size that I'm fine with. So those are also things that will impact this. But the general picture, but you got the general picture right. Yes. So you use io.async to say that, yeah, order of execution between certain things doesn't matter. Yes. And to be clear, this part here, that order of execution doesn't matter, this is a prerequisite for being able to run things concurrently. So the idea is, well, at least in part, the thing is, for you to be able to run two functions on two different threads, to some degree, they have to not care about each other. Because if one requires, if every single step of the way, one operation in one function requires a result from the other function, then you're just going to mutex all the way between two threads, right? Ping pong these mutex, essentially collapsing everything into a single threaded execution effectively at the end of the day. So you need some of that. The key point is some things can be also scheduled sequentially and it's still fine. The examples that we use usually are like save file A and save file B, where those functions entirely do not care about one another, and so you can do first one, then the other, a bit of each, and whatever, and it is fine. While some other functions have a slightly different relationship. They mostly want to act independently, but at some point they do need to synchronize. Those are the pesky ones. So, for example, you start a server, but the server will not shut down until it has seen a client connect and it has it has served it has replied to a client request. So that means that you have to start a server with concurrent because you need you need the server to be running, and also you need to run the client at the same time. They need, like, the execution of these two things needs to overlap. With save file A, save file B, you can put them like this, you can put them like this, you can overlap them a little bit on two threads. All of these combinations are fine. With the server client example, again, under the assumption that the server is not requires it's expecting a client to connect before shutting down, then this is fine. This is fine, right? They do have an overlap. So these overlaps are fine. They have to overlap a little bit. But the problem is that the moment you try to schedule them in sequence, that is impossible because the moment you try to do it like this, then the runtime of this one will extend indefinitely because they will have an infinite loop. Well, unless you put a timeout in there, but then I guess the idea of the timeout is that it's a failure. It's not a success. So for the thing to succeed, like, let's imagine that you have an infinite loop waiting for the connection to be established, or like from the perspective, let's say that this is the server. So the server is waiting for a client to connect. This thing will wait forever. And so you're never going to be able to reach the second step of execution. So that's the difference. And we mark that with io.async and io.concurrent so that you can safely know when a piece of code can be run in single threaded mode and when it cannot. Also, we should specify single-threaded blocking I/O mode, because if you have evented I/O, then you can do things concurrently also in single-threaded. And there's basically you need to use something like I/O routing for I/O, and then you need to have either green threads or stackless coroutines. Generally speaking, it's not a hard requirement, but that's the kind of strategy that you need to have. Okay. Um, let's see. Streaming decompression functions. We were looking already at some of this stuff, were we not? Well, let's see. Well, you keep calling it. I mean, this is not particularly interesting. I think this is fine. Oh, when an operation returns with an error code, the ZDS state may be left in undefined state. It is UB to invoke ZSTD decompress stream on such a state. In order to reuse such a state, it first must be reset, which can be done explicitly. Or it is implied for operation starting a new decompression job. Simple dictionary API. Bulk processing dictionary API. Okay, so we're getting to the stuff that we care about more. Okay. ZSD compress using dict. Compression at an explicit compression level using a dictionary. Dictionary can be an arbitrary data segment, also called a prefix. Oh, the dictionary is just a string? That is interesting. I expected it to be hmm, you know what? Let's read more. This function loads the dictionary, resulting in significant startup delay. It's intended for a dictionary used only once. Okay. Decompress all the way around. Okay, this is the more interesting part. Bulk processing dictionary API. When compressing multiple messages or blocks using the same dictionary, it is recommended to digest the dictionary only once, since it's a costly operation. Create cdict will create a state from digesting a dictionary. Okay, so you provide a dictionary as one string, but you will provide the dictionary as one string, but the thing will do stuff to it for it will create an internal representation. Okay, that makes sense. The resulting state can be used for future compression operations with very limited startup cost. So you create it once and then you're shared. Oh, and it can be shared by multiple threads concurrently. Oh, this is delicious. Since its usage is read only, right? Then you can dict buffer can be released after creation because content is copied within cdict. Wait, what? Dict buffer? Oh, right. Okay, so it doesn't reference the original data. Okay. Consider experimental function create cdict by reference. If you prefer to not duplicate dict buffer content, these motherfuckers. So this this would be fine, but it would need to you need to make a version of this that accepts a vector. So it accepts a slice of slices. This is where this thing really shines. Hello world gets compressed like 0, 5, 6, 10, where the numbers are a slice of the dictionary. Mm-hmm. If you prefer to not duplicate the buffer content, a ZSD cdict can be created from an empty dict buffer, in which case the only thing that it transports is the compression level. This can be useful in a pipeline featuring using cdict exclusively, expecting a dict parameter with any data, including those without a known dictionary. Okay. Compress using cdict. Compression using a digested dictionary. Recommended when the same dictionary is used multiple times. Decided dictionary creation time. And frame parameters are hard coded. Dict ID, yes. Content size, yes. Checksum, no. Okay. Create dict. Free dict. Decompress using ddict. Okay. So this means that this is not streaming though. This means that if we want to use the dictionary version, then it means that we need to define on our end which things are compressed. I think it's fine. I think we can do it. I mean, the way we can do it is simple actually. We basically in our In our compression metaprogramming, we simply just say that whenever something is a slice of bytes, it's like a slice of const u8. The process for decoding that is not just copying the bytes directly, but it is running them through a dictionary first. Compression decompression. Do you need streaming compression for this? Mm, I think streaming compression is basically making a dynamic dictionary based on a window. Um, Streaming compression. Well, the beauty of streaming compression is that you can apply that to the TCP stream. So if we were to use this explicitly, we would have at the application level decide which fields. I'll give you an example. We are gonna say that whenever. Oh no, I press buttons. I should not have pressed buttons. That's on me. I've been. Man, button pressing is my passion. Let's look at message. So what we can say is that this type, I'm not going to implement it this way, but just to explain the concept, we're going to say zstd of text. So we're going to say everything else goes around uncompressed. I mean, these are numbers, so fine. But this is text, and we're going to compress it, and and then there's like metaprogramming code for serializing and deserializing, which you can see actually here. Oh, we were already personalizing this. In any case, um, we can have custom code that then knows how that this needs to be compressed and decompressed. And this will work with the dictionary approach. But if we instead we did the streaming approach, then we would be able to do this. In run TCP accept, whenever we accept a function, instead of using this reader and this writer, we make a zstd. We wrap them into a zstd writer. Again, this is pseudocode, but you get the idea. We make, oh, sorry, this is a reader. Zstd reader, zstd writer. And then we just call it a day. And then we just leave it at that. And this would attempt to compress everything. It would try to compress text. It would try to compress numbers. Numbers might be compressible because um, some numbers are going to be timestamps, and they will be user IDs, so there will be some repetition in there, and then some will be timestamps, so they will be, I mean, at least partially correlated. Let's just say. So that's the idea. I don't know which is better. Okay, so we were around here. Let's see. Get dict ID. Get dict ID from dict. Get dict ID from c dict. From d dict. From frame. Advanced Dictionary and Prefix API. This API allows dictionaries to be used with ZSD compressed too. Oh, whoa, 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 whoa. This API allows dictionaries to be used with compressed stream too. So they're lying. So you can use dictionaries with streaming. Dictionaries are sticky. Also, why am I clicking here and then there's a thing here? Hello? GitHub? Microsoft? This is a non-editable text box. Why does it behave like this? Like, what is this bullshit? Let's see. Dictionaries are sticky. They remain valid when same context is reused. They only reset when the context is reset. With ZSCD reset parameters or ZSCD reset session and parameters. In contrast, prefixes are single use. Is it editable? I mean, but when do you ever edit this thing? I mean, if you're saying that technically this is implemented as a text box HTML element, um, I guess. But the point is, functionally speaking, you don't edit documents from this view, right? You go to a different view for editing. Ugh. CCTX load dictionary. Create an internal cdict from dict buffer. The compression will have to use the same dictionary. Result 0 or an error code. Special. Loading a null or a zero size dictionary invalidates the previous dictionary, meaning return to no dictionary mode. Dictionary is sticky. Loading a dictionary involves building tables. It's also a CPU consuming operation, which is non-negligible impact on latency. Tables are dependent on compression parameters, and for this reason, compression parameters can no longer be changed after loading a dictionary. Dict content will be copied internally. Use experimental ZSCD CCTX load dictionary by reference to reference content instead. In such case, dictionary buffer must outlive its users. Load dictionary advanced to precisely select how dictionary content must be interpreted. This method does not benefit from LDM, long distance mode. If you want to employ LDM on some large dictionary content, prefer employing the SED CCTX ref prefix described below. Load dictionary, CCTX, dictionary dict size. So you can put dictionaries in streaming. Like they spend so much time saying, no, you cannot use dictionaries with streaming. And then here's how you load a dictionary in streaming. Fine. Ref C dict. Reference a prepared dictionary to be used for all future compressed frames. Note that compression parameters are enforced from within cdict and supersede any compression parameter previously set within CCTX. Parameters ignored are labeled as superseded by cdict in the SDDC parameter enum docs. The dictionary will remain valid for future compressed frames using the same thing. Okay. Ref prefix. Reference a prefix single usage dictionary for next compressed frame. A prefix is only used once. Tables are discarded at the end of the frame. Okay. Load dictionary. Create an internal ddict from dict buffer. Okay, so this is basically for decompression. So we've seen the compression side. We're seeing the decompression side. Okay. Also, load versus ref. So this creates and loads. This one just references. So you can share it, I guess. Okay, memory management. Size of this, size of that. They give the current memory usage of selected object. Note that object memory usage can evolve, increase or decrease over time. Advanced and experimental functions. Okay. Let's go. What do we have in here? Experimental API static linking only. Yes, 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 yes. Compression parameter bounds. Okay. Advanced types. Wait, where did the stuff go? I guess it starts with just some definitions. Do you think if I study JavaScript and algorithm and data structure and solve problem in lead code, do you think I will be ready for finding a job? Um, I've never solved the lead code problems myself, but the answer is um not exactly. So it's probably not a bad thing to do, I guess. It depends where you live. If where you live, companies ask you lead code questions, then yes, do practice lead code because then you will pass that part of the interview. But to answer your question more broadly, um, your company, so you will still probably be a junior figure. And to be a more senior figure, you need also other kinds of experience, mainly like real world experience. So, like, sorry, my point is, yes, you can do that. My point is, don't just do that all the time and think that this is the only thing you need to do to be able to find a job. But yeah, if you're looking for a front end developer position, and if you don't know much about algorithms and data structures, learning about that a little bit is good. You do want to know the difference between an array and a dictionary, for example. Um, Solving problems in lead code, it can be helpful if the companies around you ask you to solve lead code. Another thing that you could do is trying to have a bit of a portfolio, or in general have some experience. For example, I assume that you said JavaScript and then you meant front end, but that's actually not necessarily true. You might be interested in JavaScript to do like backend still. But in any case, whichever it is that you're interested in, uh, do do, um, do gain some experience with that. So if you want to do front end, uh, try to make a nice personal website, and then try your hand at making a more complicated website, like I don't know, like um, an e-commerce website. I don't know, that kind of stuff, so that you can get some practice. My point is that lead code is too synthetic to teach you how to do things in the real world. It can help you with the interview. That's all it can do, assuming that you get asked lead code questions. Um, it's way too synthetic. So yeah, make a personal website. If instead you're looking for backend work with JavaScript, first of all, make sure that the type of job that you're looking for that you can apply to is looking for JavaScript backend developers. Like for the front end, there's not much choice. It's like JavaScript, TypeScript. That's kind of it. But for backend, there's like plenty of options, and maybe JavaScript is the right one for you. Maybe not. So be careful also about that. So the point is, don't just do lead code. Lead code is only useful for passing the lead code part of the interview. That's pretty much what it is. It's not useful in the real world. I'm probably using the wrong term, but by stream compression, I mean a dictionary per stream that's tracked and updated by client and server. I assume you would be fine by just having a static dictionary compressing the writer buffer all at once before flushing. I assume you don't plan the ZSD writer to be unbuffered. Yeah, no, it is not unbuffered. Also, not only it is not unbuffered, but there's also the fact that um, in theory we could have we could have an interface that is better than just a writer interface, because um, some messages will serialize on the fly, that like they write themselves to a writer, but some of them, the ones that get repeated, the ones that get broadcasted out to multiple clients, they will serialize themselves in memory, and then those bytes in memory are going to be sent to multiple clients. So my point is that for messages that we fan out to multiple clients that we see serialized in memory all at once, then we could do something nicer than what you would be able to do by implementing a writer, I think. Lead code problems are the worst kind of programming problems. Yeah, they don't map one to real problems. They're synthetic. I think the best way of describing it is that they're like extremely synthetic. So yeah. Hope you had a good day. Well, thank you. You too. Okay, where are my experimental functions? Frame header and size functions. No. Okay, frame header advanced. Decompression margin. ZSD supports in place decompression. Mmm. Yum 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 yum. Where the input and output buffers overlap. In this case, the output buffer must be at least margin plus output size bytes large. And the input buffer must be at the end of the output buffer. Well, that makes sense. That's also cool. In place decompression. I think in our case, this could be mildly interesting, but it doesn't matter much. Originally, when I first designed the protocol, I did prefix messages with their length, and like I would prefix this type of information, but we don't have that anymore. I think it's fine to have a bit of dynamic allocation happen. Okay, this is not particularly interesting for us, I would say. Sequence bound, deprecated for debugging only will be replaced with extract sequences. Merge block delimiters, compress sequences and literals, write skippable frame, read skippable frame, and management. Wait, we were promised experimental APIs. We didn't see any fucking experimental API. Where's the reference dict stuff? Init static d-dict. What? Init static star. Initialize an object using a pre-allocated fixed size buffer. Workspace, the memory area to emplace. Provided pointer must be 8 bytes aligned. Oh man, if only there was a way in the language to express that the pointer needs a certain alignment. So I guess this thing needs to be 8 bytes aligned because they plan to plop a struct in there, I guess. Or you know what? Actually, there might be a variety of reasons. They also probably want to use vectorized instructions. So buffer must outlive object. Yes. Workspace size. Use the STD estimate whatever size to determine how large workspace must be to support target scenario. But those are functions, they're not macros. Return pointer to object, same address as workspace, just different type. Or null if error, size too small, incorrect alignment, etc. ZSD will never resize nor malloc when using a static buffer. If the object requires more memory than available, ZSD will just error out, typically memory allocation. There is no corresponding free function. Yeah. Get C params to convert a compression level into its associated C params. Currently not compatible with internal dictionary creation triggered by CCTX load dictionary, C stream using dict, init D stream using dict. No, well, that makes sense. Static CCTX currently not compatible with multi-threading. Static DCTX is incompatible with legacy support. Okay. In our case, how interesting is this stuff? For the client, not at all, because the client will dynamically connect, disconnect, add, remove hosts that it connects to. So, no, we can't use static memory for that. For the server, well, the server has kind of, well, it's the same relationship, just the other way around. A server has clients flying in and out, so can't use static memory for that either. Um, so yeah, custom memory allocation. These prototypes make it possible to pass your own allocation-free functions. Thread pool? What? These prototypes make it possible to share a thread pool among multiple compression contexts. This can limit resources for applications with multiple threads where each one uses a threaded compression mode. Create thread pool creates a new thread pool with a given number of threads. The lifetime of such pool must exist while being used. Huh? Man, these dogs. Man, these dogs. Ref thread pool assigns a thread pool to a context. What is this stuff? This API is temporary and is expected to change and disappear in the future. No, Critic Advanced. No, my beloved. I actually have no idea if I would even care. It's just dictionary related. They were mentioning it above, though, that there was like the advanced dictionary creation stuff. Dict size, dict load method, dict content type, CCTX params, custom mem. Advanced compression. Oh, there we go. Create cdict by reference. Create a digested dictionary for compression. Dictionary content is just referenced, not duplicated. As a consequence, the buffer must outlive cdict, and its content must remain unmodified throughout the lifetime of cdict. Yeah. Equivalent to cdict advanced with dict load method equals zsddlm by ref. Oh my god, man. You know what? These people, I'm trying to understand if these people are like C++ programmers who clearly feel like claustrophobic using C, because they would like to have all kinds of weirdo metaprogramming and they just can't pull it off, and so they're ping ponging between normal functions and functions that have like this concept of accepting like a bunch of enums, that kind of stuff. Either that, or either they're yearning for the C++ or they're yearning for at least something like Zig. Is there any aligned by like thing in Zig? I don't know what align by does. Is that a C thing or is that a C++ thing? In Zig, so for example, earlier they were asking for a pointer. So they were saying you can provide a pointer to some memory. So I guess in C there would be I don't know what would they do? They would call it like a char star uh memory, maybe. But um but they were saying that this needs to be 8-byte align. So how would you do this in Zig, sorry. In Zig, first of all, you could say that the thing is a pointer to some byte. It's like a slice of bytes, or a pointer to a unknown number of bytes, and you do it like this. Um, but probably the way you would do it is that you would pass around a pointer to any opaque. Let me think about it. How would I do it? I guess you could do it either way. But here's the thing. Let's talk about alignment. So here's how you do it in Zig. So you would do const memory. Uh, of this kind. Or okay, let's do the full realistic thing. The full realistic thing is, but that would be static memory, right? So never mind. Okay, so if it were static memory, then you would do this buff. Let's say that you do 1 kilobyte, so 128 U8 equals undefined. So this is your memory, and then you would need a pointer to it. So you would do const memory equals pointer to this, and you set memory to be this. So this also works. But this doesn't explain the alignment property. So the alignment property needs to be a property of both the pointer and the memory. So if you do it like this, I think this is not correct. Um, what is happening right now? Run client manager. Uh, what did I break? Sorry, you had some weird errors that are causing Zig to not tell us about what I was doing in there. Expected what? What is expected? And expected statement from the document comment. Oh, Jesus, relax. Expected expression found const. Sorry, when did all this happen? What did I do in there? Think compute delta. Okay, sorry. Let me fix my code. Then I'm gonna come back to this. Rank be and what is your problem, dude? Hey, and Andrew, you're up a bit late, aren't you? Also, why are you coming in exactly at the most embarrassing moment where somehow the code is broken? I was just trying to show something and then the code is broken. Expected expression found const. Expected expression found const. How the heck? So there must be something wrong nearby. You know what? Let me cut this out. What else did I break? What is this? What did I break? Function. Also, I wasn't even touching this. This is driving me nuts. I wasn't even touching this. 217 and 215. Oh no, that's a rebuild. Okay. 215. Expected expression found const. So this one is fine. Is it something up here that I messed up? Okay, so out of curiosity, what if I commented this whole function? What about now? Use an unclear identifier. Yes. The fare is missing a closing thing. Oh. Also, you know what? This was complaining that this could not be a triple comment, but this should definitely be a triple comment because it's not comment for this function. A defer is closing a is missing a curly. Which defer though? This one? No. I guess a previous defer. Oh, this one. Yeah. Jesus. Okay. Back in business. Let's bail out. Let's go. No, okay, we can do stuff in here. Okay, now that this stuff works, um, now I don't know. Maybe this is. Oh, there we go. This is the error that I was looking for. So, this is something that when I was like just getting started, it took me a moment to understand. Although it's obvious in hindsight if you think about it. So here we are defining some memory, and then we're grabbing a pointer from it, and we're saying that we expect this pointer to have an alignment of 8. But this code doesn't guarantee this at all. So why does it not guarantee this? Because the pointer says that it wants to be a pointer aligned to 8 bytes, but the the pointer number originates from this definition. So this guy doesn't control it. This is just setting an expectation. And so we need to say also that the memory has to be aligned correctly. And I believe that you do it like this. So you would think, wait, you do it like this, right? I mean, that would mirror, but no, that's not how you do it. I think you do it like this. Now, if you save and give it a moment, I think everybody will be happy. Or not. Oh, no, you know what? The problem is constness. You want this to be var. Now we're happy. What if I take out this align 8? We'll be unhappy? We'll be unhappy. And the error message is, drum roll. Oh, sorry, yeah. Oh, whatever. No, it closed the wrong thing. Oh my god. Isn't it Control J? Okay, there we go. Expected align 8 found this. Okay. But this number doesn't matter for the alignment. Like this could be 77999 and this would still be fine. In any case, I hope these answers sorry, went on an adventure. I hope these answers the and I made the mistake of looking at the news before bed. Oh no, what has Microsoft done now? So yeah, it's easier for us. Like I personally have never really understood alignment in C before because in C you don't have an option. Like you don't see it. Like in here, this all makes sense. Oh, I want some memory. I need to specify the alignment. I have no idea how you specify the alignment of a variable in C. I'm assuming you can, but I think I've never seen the syntax. Does anybody in chat know? Like, what's the equivalent of this in C? Also, here's another one. Got a malloc. Whenever people use malloc, they have no way of specifying the alignment of malloc. Of memory allocated by malloc. So it always seemed so like weird to me. And then it turns out that apparently allocators in C implicitly do maximum alignment, um, which I didn't know. It's always word alignment. You need POSIX mem align for that. Malloc is always 16 bytes aligned. 16. So that you just don't go wrong. POSIX memo line for that. Jesus. But what about variables? So what about stack variables? Is POSIX memo line a stack variable thing, or is it a malloc alternative with alignment? So in any case, for people curious, here's how you do it with allocators in Zig. So you would do memory equals GPA dot aligned alloc, type U8, alignment, in our case, it would be 8, and then, 999. There you go. And if we do this, so let's get rid of this. If we do this, there's only one problem. I don't think we can cast this to a pointer to an unknown number of bytes. Let's see. I think this won't work. Yeah. Why? Well, first of all, I think this needs to be tried, or we need to catch errors. Oh, wait, this number is a more complicated type. Okay, let's do all the things. Catch, I don't know, unreachable. Then align unlock. So this is let's go find out about that type. I forgot how it works. Alignment. Or we just literally do .8. Or we could do from byte units. So either this. Did I get out of completion from this? Oh no, I'm getting wrong out of completion from ZLS. From byte unit. Is it byte unit or bytes unit? Byte units, right? Okay, it's essentially the same thing. Oh, what's the problem here? Expected type these found this. Oh, first of all, this function tells us that it's returning something 8 aligned. But here's the problem. Even if I put align 8 here, this is very basic stuff if you have experience with Zig. The problem is that this gives me a slice, while here I want a pointer. A slice is a pointer plus length, and Zig is not allowing me to silently discard the length information. I need to do that explicitly. So I need to do this, and then let's call this memory slice, and then I would need to do const memory equals memory slice.ptr. Slices, I have len and ptr. So you do ptr, and you will see that this is, I'm going to say usize, just so that we can observe the error, tell us what we're doing wrong. Expected usize found, there we go. You see that now we got the right type, which is a pointer to an unknown number of bytes aligned to 8. And now everybody's happy. Well, we need to discard the unused variable. And now everybody's happy. Let's see. The other thing is a malloc alternative. Compiler extensions allow variable alignment. Maybe the new C11 standard finally supports it. If you don't keep the alignment on the result, you'll cause problem with 3. Oh yeah. Yeah. So so you can do this. I think this will silently work. So here if we do this, we are silently dropping type information. And what Andrew is saying is that if you drop this type information, then when you call free will not be able to observe this type information and the alignment requirement. And so apparently that will cause trouble. Okay, so you got to preserve it. Anyway, so I don't know. ZSTD seems cool. By copy, by reference. These docs in ZSTD are like wild. Clearly, who had to write this document, like these comments, did not want to do that. I can see that there is no love in having to provide documentation to users. Oh man. No, there's no Awebo syntax. Actually, there might be some. I think I saw another weird one. You know what? There is some. Not a lot. But I think somewhere I saw a. I think I saw a. This bang and then lower than sign. I guess we can search for lower than sign. There's not that many. Ah, there we go. These guys. Yeah, the joke is that basically, so um for Awebo you can see here in the um, in the description, this is like a bird speaking. So I use in my CLI a live bird and then dead bird, uh, and then technically there's also bird shouting. But bird shouting, what's funny is that apparently is Doxygen syntax. So this one has a question mark, an exclamation mark, sorry. But sometimes you see slash star star and then open beak, and to me it looks like it's a bird shouting the comment. Yeah, actually observing this, what's funny is that observing this is what made me think of making this thing. Oh man. Anyway, so here's what I'm gonna do. I'm gonna get some tea. I just need to pour it in my cup, and then let's make a new project and let's see if we can get ZSTD working at all. I do wonder how. You know what? I really think we should try to write a reader and a writer for ZSTD. I've never done this work. The new reader and writers do seem a little bit intimidating, um, but why not? Like, why not just have a ZSTD reader and writer and see what that does? In Zig, how can I check if our locator fails because of not enough memory? Um, every time you call the allocator, so you do, for example, const, let's say that we have a person and we want to hip allocate a person. Well, let's say that person just has age for simplicity. User 32 should be enough. Okay, whenever you want to create a person, you do const p equals gpa dot create. So this is just one person, and we're trying to create one person. This will return to us a pointer to person, or rather, no. Let's watch Zig tell us what we're doing wrong here. Give it a moment. So that it builds. This is a big project. I'm adding random code to. Oh, sorry, I'm missing an equal sign. Did I nuke QBuff? Wait a second. I think I nuked a line by mistake. How did I ended up doing this? Okay, here you can see expected type T, but we found error out of memory T. So create will return you an error. It will return you an error union. So you either try, and try means that your function needs to be a function that can return an error. We use an exclamation mark for that. And so you're basically bubbling the error up. Sometimes this is appropriate. Some other times you have to do stuff on right here. So alternatively to try, you can do catch. And then you can do something in here. For example, this would only fail with out of memory, but sometimes you can use a function that will fail with out of memory and also with other errors. So you will want to also switch on the error. And in which case, when you see error dot out of memory, this is unnecessary in here. I'm just showing the more general use case. So when you see error out of memory, what do? Here, you decide what to do. So you could say, well, I'll try to make a person, but then this can fail. So you're saying that a person is optional. So in this case, if you do this, you could basically, you could do this. What this does is say, accelerator from out of memory. Oh, I'm missing of. So what this does is say, well, we'll try to create the person, but then if it is out of memory, we'll set it to null. Again, this syntax is a little bit complicated because I'm assuming that there might be other errors, which is not the case for GPA. So like with GPA, you could do this. This would be the exact same thing. But let's imagine that there are other errors that could come out of this. If another one is error dot, I don't know, there's some network access and I don't know, the network access goes wrong. I don't know, network error. I'm making this up. In the case of network error, maybe you want to do std log dot error blarg dead. And then you do, actually, instead of log error, you do this. You do std dot process fatal blarg dead. And basically, this is going to close your application with a non-zero exit code. It will do exit 1. It will print your error message and then exit 1. And so that's another thing that you can do. Obviously in a real application, there are some other strategies that you could employ. But the point is, allocation always returns you an error. You always have to handle it one way or another. It happens often that it's not easy to get out of memory situation while keeping everything working, but it can be done. Do we have it in C? In C, the way it works is that you call malloc, and malloc is supposed to give you, I don't remember what arguments you pass to it, but malloc is supposed to give you a pointer to your thing. So you would do something like this, I think. Struct person P, struct person star P equals malloc. Somebody correct me. C programmers correct me if I'm saying something wrong. So let's imagine that you still have the person that struct definition in C. So you will get something like this. And then you would have to do if P is 0 or null. And here you handle out of memory. But at the same time, it's just a size T. Oh, you're right. So you would do size of. Do you even put parentheses after size of? I think you do. So I think this is the C syntax. So P equals null always means Yeah. With malloc, yes. But here's the problem more in general. C projects almost never check for this being 0. They almost never have this. They almost always do this and assume, actually the star you're supposed to put next to the variable, right? In any case, C projects almost never check for malloc fading. In their defense, if you do have overcommit enabled in your operating system, then your system will say yes, even if it has run out of memory, because it's hoping that you're not going to use that memory. It's hoping that you think you're going to use that memory and then you're not going to do it. But then what happens is that the moment you try to write to it, so the moment you try to do p age equals 10 or whatever, 30, 40. So the moment you do this, then you get a crash. You get killed, or either you or another process is gonna get killed. This is also true for Zig. Like in Zig also, if your system has overcommit on, your gpa.create will succeed, and then you will get a crash when you try to access that memory. But when you program Zig, you shouldn't assume that you have overcommit on. You should assume that your code might be used also and deployed on systems that don't have that. And if it's a library, especially, it might be used on on an embedded device, for example. So Yeah. Can you even have yeah, so this relates to what I was talking about. Yeah, no, you can 100% have You can have because you hit uh limits that are imposed to your user slash your process. Like you can set limits on how much memory a process can allocate, for example. Um, you can have systems where you turn off overcommit. Yeah, you can totally do it. Like overcommit is not inherently good. I think it's generally good to have. Like you want that sometimes, but not all the time. So it's kind of a bad idea to assume that malloc cannot fail. That being said, it is hard to manage out of memory in a way that makes sense. So I think it's reasonable for application developers to not necessarily model that perfectly when they're starting. I certainly, for example, with Awebo, I'm putting a bunch of uh, calls to fatal whenever allocation doesn't work because I don't know yet how I want to structure recovering from that. But the point is, it is possible. It could be that we get to a point where we're going to start modeling what happens when we run out of memory. For example, here's what the server could do when it starts running out of memory. It disconnects some clients. Look at the oldest client in that has not done anything, kick it out, reclaim all the resources that thing was consuming, and trying to survive. As an example, the client could also do something similar. Like the client could disconnect and free all cached resources for the like imagine that you're in the client and you're connected to multiple hosts at the same time and you have one tab open, and the client, if it's running out of memory, could say could disconnect the other servers and free associated resources uh so that it can keep going. Okay, let me go get the team. Here I am. Hey chat, just joined watching. Can someone tell me what is overcommit? Yes, overcommit is basically your having your system operate kind of like a bank. So the idea is let's say that you have 2 gigs of memory. Like you literally have a one stick of RAM that has 2 gigabytes in it. And that's it. So without overcommit, whenever you try to allocate memory in a program, you ask 10 bytes, 1 kilobyte, 5 megabytes. Whenever you ask for some memory, without overcommit, the system will say, okay, I have 2 gigabytes. Well, the operating system will use some of that memory, but for simplicity, let's imagine that the OS does not need that. So the OS will say, okay, I have 2 gigabytes of memory. I've allocated 1 kilobyte here, 1 megabyte there, 1 GB some other place, and then if you allocated more than 1 GB in multiple allocations, and somebody then asks you, the OS, for 1 more GB of memory, then the answer has to be no, because we ran out. With overcommit, DOS, what DOS will do is say yes also to that 1 GB allocation, and then hope that the program doesn't try to access all the memory in that gigabyte worth of address space. Because the OS has the ability to give you whenever you allocate some memory, you're basically being assigned like a range of addresses, and which are like numbers that then have to map to your physical RAM somehow. But this mapping, this virtual memory, allows this mapping to change dynamically, and so a given range that of addresses that you give to a program doesn't have to be necessarily assigned right away to physical wires and bits in your RAM sticks. So your OS can basically go in depth or do overbooking, like Andrew is saying with airplanes. So what is the advantage of this? The advantage of this is that a program can ask for more memory than what it strictly needs. I guess overcommit is, at the end of the day, a protection against programs that ask for too much memory in some ways. But yeah, the downside of this process is that you basically what happens is that a program that tries to allocate some memory is going to be told yes, even though when the real answer is no, there isn't any more memory. And so the program loses the opportunity to react to an out of memory condition. So what ends up happening is that necessarily, overcommit turns what could in theory be an error condition that could be managed by a program into an inevitable train wreck. Because what ends up happening, and this is what I was showing earlier, what ends up happening is that this will not error out. This will result in a non-null pointer in C, or in Zig it will result in a it will result in a success, so it will not result in a out of memory error. But then when you try to access that memory, this is where the OS will say, well, I was trying to be optimistic and hoping that I would have some free bits, like some free space in the memory sticks to give you by the time you needed to access this memory for real. But turned out to not be the case. And so somebody has to die, which is either you, this process, or another process. Like the OS can even decide that you're trying to access this memory for real, so it has to map those numbers for real to real wires. But then the price for this could be paid by somebody else. So there's another process, a process that has been an innocent process, that has done nothing wrong, has always lived a simple life, only used the memory that it strictly needed to survive, and yet that God-fearing, law-abiding process will have to be killed for you to use this. I think in reality, processes, I think the order in which these processes are killed is like the more memory hungry ones tend to be killed first. So I guess there is some form of justice also when it comes to the killer, but yeah. And then there's also a list of processes that cannot be killed. Yeah, why don't we keep running an AI that eats by itself 16 gigabytes of RAM, and then what it does is decide who gets the other 16 gigabytes in the system? Holy shit, I think I've just invented politics for computers. Oh man. Uh, what's the benefits of this approach? You mean having overcommit on? Overcommit on, yeah, overcommit on allows you. It's kind of like it's the same thing as the airplane stuff. For example, it allows you, you know, I'll give a different example, which is actually it's just like a different skin on Andrew's example. But when organizing events, for example, I've been organizing Zig events for a while, and you book a room, like you have a location um that can have up to, I don't know, like let's say 20 people that can stay in it. So your meetup can only have 20 people in it. But then when you open the event, like it's a free event, so whenever people sign up for your event, if you put the limit to 20 and then at 20 you cap it off, you're guaranteed that there will be no shows. So if you do 20, you're guaranteed that you're never going to fill all the seats. So you, for a 20 seat room, you will want to put, probably you will want, you decide what you want, but you can afford to put like 30, even 40, um if you want. Depending on the type of event, you could put 40 and be guaranteed that, and then you will have a chance to get up to 20. Of course, like with the killer, also in that case, you basically can potentially cause a disaster, because turns out that the one time where more than 20, the one time where all 40 people show up, you're fucked, because like half of your attendees won't have the ability to see it or won't even be allowed in the room. So that is a problem. So what you want to do generally is like find a sweet spot and in between. I think that when it comes to events, it makes sense, like free events especially. Paid events, yeah, not so much. But when it comes to computers, I really cannot think of this as just a cope for sloppy programming. Like because there are some things that you can do, like some games that you can play with memory, with address space. But I think that you could, for example, here's an argument that one could make. But wait, what if I want to have the ability to have one contiguous array, one very big contiguous array, and I'm not gonna need all the memory right away. But I know that if this currently tiny array has to grow, I want to be able to resize it without having to move it. And so you could say, and I want to make sure that this array can grow up to 20 gigabytes, 50, 70, 100 gigabytes. But I believe that you can still do that without asking the US for an outrageous amount of memory. I believe that there's that there are APIs for reserving address space without implying that the address space needs to be really mapped to anything. And so if you, once these two things are broken apart, then you can reserve the address space, and then whenever you try to say, okay, now this address space needs to really map to real memory pages, um, then that's where you have your failure point. Like you try to do that, and the US says, well, no, sorry, I ran out of pages. You'll have to do something else. So you can still do that. I really cannot think of overcommit as anything more than just people could have done better, but they didn't. Oh, no. There's another thing. Wait. Um um I guess there's fork, there's copying on write, there's copying on write and forking. I guess overcommit is a thing that supports forking, right? So in POSIX, well, in Linux for sure. I'm not sure in other language, in other OSs. I don't know if Mac does the same. Actually, it does probably. Otherwise, Redis wouldn't work on it. Yeah, so I'm guessing in POSIX systems, you have this concept of whenever a process forks, you have copy on write of pages. So the idea is you have one process, you split it in two, and then both processes have each own copy of the memory, but that copy of memory didn't really happen. They are both using the same pages, but the difference is that whenever one of the two, as long as the memory pages are only getting read, they both read the same page and everybody's happy. But the moment one of the two wants to write something different to a page, then what happens is that, okay, that page gets actually copied into two copies of it get made. Well, sorry, one copy of it get made. Like that single page becomes two pages by copying it once on another page, and then one process gets their own version, and the other process gets the other version. And I guess this whole thing kinda plays into overcommit to some degree, but I don't know. Anyway, enough with the C. Let's do the STD. So here's what I'm gonna do. I'm gonna make a new directory, I think. Compress. I don't know. Zig init. Oh, minimal. Thank you. Okay. Zig fetch save github.com all your code base zstd. New options for Zig init dropped. Minimal has been there for a while. By the way, this is so funny. The moment that people learn that minimal exists, so we went from, oh, the normal Zig init is too spammy and I don't like it. And then, okay, here's your Zig init minimal. And then people started saying, yeah, but the minimal is too minimal. I want my templates. I'm like, oh man, then go make your own templates. Like, people are never happy with this stuff. Yeah. It's like, it's like, oh man, this Zig init is too hard. This Zig init is too soft. This Zig init is too hot. Yeah. Okay, so yeah, let's use this bad boy. Okay, build a Zig. How are we gonna do it? We're gonna do const z p.add executable. We're gonna do options. We're gonna do name equals compress. I don't know. We're gonna do root module equals b.create. Can we do create module and give to it C files? Well, it doesn't matter. We're not doing that. We're just giving it ZSTD as a dependency. Never mind. So create module to do. Well, imports. I think it's what's the shape of imports? It's a slice of import. Import is name module, right? So import is name module. So this should be wait, was it a tuple? No, it's a struct. Okay. Name is gonna be ZSTD. Module is gonna be ZSTD mod or something. We're gonna figure this out in a moment. Let's get ZSTD going. Dependency. Oh shit. ZSTD. Args. ZSTD has a bunch of options. We're gonna do target and optimize for now, but you know what? I'm starting to think that the minimal build script should have default options and default optimizing. Um, now I'm talking about the Goldilocks template. Target equals b dot standard target options. Optimize equals b dot standard optimize option. Also no weird options. ZSD is gonna target is gonna be target. Optimize is gonna be optimize. There's more options. There's a ton more options that we should explore, but for now, imports to do name is ZSTD module. Gonna be zstd.module. Actually, does it have a module? Wait a second. No, I'm doing it wrong. We're not importing anything. That's not how it works. Because I think this is a library that doesn't have any of this stuff. It only has it only links against the C library. So we're gonna have to use other stuff. So root module is gonna be target equals target. Optimize. Oh. Optimize. We're missing a root file. Root source file is gonna be b.path source slash actually, you know what? We're not even gonna have source. We're gonna just have main.zig, I guess. And exe dot root module dot add link library. I think ZSTD. No, I'm dumb. Wait a second. ZSTD could be exposing module. ZSTD should be exposing module. Okay, I'm getting confused for no reason. Let's take a look at what it has. Well, we don't know how they expose it, so we have to learn from their build script. But they could be exposing a module. They should be exposing a module. They do have library, so never mind. So never mind. Library it is. So in the end, I was right. I wasn't necessarily right, but I was right. Okay. Does someone know a Zig project which comes with Python bindings? I'm looking for an example on for writing Python extensions in Zig. Ziggy PyDast is outdated as far as I know, and it is a framework for making projects that have Python bindings. Well, Python extensions, basically. If you want an example of a project that has this, I think um, I think an example is going to be mm, I think it's gonna be. I think it's PyYAML, or maybe it's not PyYAML, but there's a YAML library. Wait a second. Not this one. I'll find it. I just need a second. Okay, technically XAML could be that. Yeah. Are your dot files publicly available? I don't have anything interesting in my dot files. My theme is IU Mirage, IU-Mirage, and I'm using JetBrains Mono as the font. And that's it. So this is one example potentially. There's also a talk from this person which I recommend, but there's more resources. Give me a second. I'll find all of them. You. Um. Z date. No, this one. It's not a Z date, but this one. Copy. this talk, and this is the same guy. This is Adam. And then there's another one more recent. I forget his nickname. Romel, maybe? Ruamel. Ruamel YAML. There we go. It's on SourceForge. You can put software on SourceForge? I didn't know you could. So I believe this bad boy has a build.zig, does it not? Doc test. I think it does not have a build.zig because it's a different project. Okay, but there's a write-up. Let's see. Yeah, so this library to has like a Zig. You can either use the pure Python implementation, or you can use the. I guess there's like backends, so you can have like the pure Python backend, or the Zig backend, depending on how you install it. And you can see some C stuff in here. Where's the build script? Wait, does he not have a build.zig? I guess he's orchestrating the build more manually from the Python side of things. Okay, in any case, here's what I would say. Take a look at API about by stats. No, that's not what I wanted. I'm looking for Anton's like blog post on this because he wrote a blog post somewhere. That's what I wanted to link. Oh, there we go. Right, he has YAML.dev. I forgot. Wait, there's nothing on the root? God damn it, man. uh okay, you know what? I'll link you to the discussion here and then you decide where to go from there. That's the difference between a library and a module in Zig. Yeah. Yeah, a library in our we use C lingo for this stuff. This is a C concept, yeah. So like you would output a library, which is like a .a file, if then you would want to have that thing be part of another C compilation process, for example. But within Zig, it shouldn't be like that. Within Zig, a module is more semantic. Okay, so we link library ZSD. We're saying link library ZSD dot artifact, I think. What did they call it? I'm guessing ZSD, but I forgot. Yeah, ZSD. Okay. Linkage. Where do you specify linkage? This is one of the options that we should look into, but in this case, it doesn't matter because it defaults to static. That's what we want. That's okay. Okay, this should be it for the ZSD stuff. And then we want to do v.install artifact exe. And then we want to do const run equals or run step equals v.step run. Then we do to do a Patwin. Thank you for the prime sub. So run step is we want to run the executable. So I think we can do it all at once. Can we do run step dot depend on? I haven't written this in a while. Depend on v dot add run artifact exe. Man, if Neurosite had implemented my suggestion, this would have been so cool. dot step. I think this is it. Probably depending also on the install is not a bad idea. It's also depend on the install. Okay. This is technically it. So we now need to make main.zig. Oh, you left me on a Awebo PR? Okay, so we got building, we got running. It seems that we're also linking correctly against the STD. Obviously, we need to start using it before we can know for sure. But let me see. What did you get me? More progress towards pulse audio. Let's go. Still not working, but now prints the devices before panicking. I need to add another parameter to device iterator init. Oh, nice. Then panic to do. We're getting there. Hmm. Nice. I mean, Andrew, you should consider merging these yourself if you want once CI passes, or if you want to run locally Zig CI, um, that also works. Yeah, you do. Yeah, yeah. Yeah. I'll wait for the green and then merge it. And it should be done in like a minute or so. Okay, what were we doing in here? So we got a main going. So all right, time to start using the STD. Um I wonder if we should attempt to do the writer reader stuff right away. That would be cool. I guess we can get a one shot compress decompress. See that we what we put in is what we get out. And then after that we go for the interface. So let's go up to the simple API. Yeah, simple core API. ZSTD compress, ZSTD decompress. Also, here we need to do const c equals at the import c include. Wait, what am I getting suggested? Holy shit. ZLS? Hello? Oh, too bad that Andrew didn't catch this. ZLS is suggesting to me all the header files that we can see include. My mind is blown. We didn't have this before. Also, I wonder why we have zlib. Why the heck is zlib? TZ file. I'm guessing these are header files that are pulled in by ZSTD, but what a story. Sorry, this should be a block, I guess. Although it doesn't have to. I think that this C import is just going to be this. Might as well simplify it. Well, you don't have autocomplete for C dot. Oh, I was hoping for too much, I guess. Although we can go to definition, right? Okay, you know what? Maybe this form is too weird. I don't know. Let's. Oh, it did work after a while. Let's do the normal version. There we go. ZSTD compress. What is it that we wanted here? Wait, this is suggesting compress, but there's also compress 2. Oh, but compress 2 is the one that wants CCTX. It's the complicated one. Oh god, these arguments, man. Oh no. Okay. One by one. Destination. Destination is gonna be, let's do a buffer. Compression buffer. 1 kilobyte U8 undefined. cbuff. Oh, I also lost the tab stuff from flow. Life is hard. Destination capacity. cbuff.len. Source. Compression level 1. Okay. What does this return? Value or type U size. So this is written. So now we can do, well, let's print this information. Also, you know what? Let's use log. You see, the pulse audio stuff reminds me I have a branch of me porting Meson or static pipewire to 016, but it seems there is no need. There's needs for some patches landed to translate SIM. Is it planned to use pipewire for both video and audio in the future? Somewhat. So as far as I know, this is probably going to be how we do it. But we have not committed to it. So the reason why Andrew right now is using doing pulse audio is because he's just worrying about getting audio off the ground. So what we're going to do is get audio off the ground on Linux using pulse audio. We already have a Windows implementation which should be fine using Wasapi. After that, we need a core audio implementation. So we're going to go like native on each platform. Then for the video stuff, I don't know. It might be that for the video stuff, then we switch from Pulse Audio to Pipewire, or maybe not. I don't know. I generally do not know. I know that on Mac you have to do video, you have to do a bunch of Objective C. Yeah. Wasabi, I don't know, man. Every time I go eat sushi, I always leave the wasabi. Maybe I take a taste. I don't know. I just a taste to see it to feel it tingle, but I never eat the wasabi. Never go full wasabi. Objective C sounds fun. Yes, I remember that before I well, not abandoned, but like I was working on Awebo a while ago, and then I stopped because we didn't have good async IO, and I was using libxcv, which had bugs with the UDP implementation that were annoying. So I basically ended up like shelving the project, waiting for uh waiting for um well, the async IO to become better, or rather the IO to become better. Um and Yeah, so sorry, brain fart. My point is, back when I was trying to do this stuff, I remember getting to the point of trying to get video working on Mac, and I remember seeing all the fucking Objective C that I had to deal with, and I didn't have a good strategy. Hopefully somebody can come up with a good strategy this time, because I guess there are two options. One is you write actual Objective C, which requires you to know how to write Objective C, or you write Zig code that mimics Objective C, because you can also do this pure Zig version. So I don't know what's worse though, honestly. I think that for simple stuff, faking Objective C from Zig is doable. But I suspect that for video, like for screen sharing, there's so much Objective C that you have to do it. That's my fear. Yeah, he's not the only one. I think yeah, I think he does. I think there's some more examples out there. I just never studied them in detail enough to really know. Um, oh wait, what am I doing? This is not sentence. This is debuff. Okay, what does this return? Decompress land. Okay, let's see how this program does. Then we panicked. Oh shit. So hello Bananarama. Length 32. We didn't gain much. Compressed data. Bunch of bytes. And then our original string. Original len 23. The compressed len is a bit too much. I'm misusing this API, I think. Let's see how decompress works. I might be misusing it. Destination capacity. Oh no, you know what? I think we got an error. So you remember when I was saying I wonder how they're gonna do they're gonna stuff errors in the return value? The answer is um they're gonna do it by using huge numbers. So we need to do CSCD is error. I don't know. Is this something? Is zero gonna be not error? I assume. We'll see. Decompression error. Source size is incorrect. Destination. Oh, I swapped these arguments around. No, it's not. Destination length, source, compressed size. What are we missing? Okay, what are we missing in all of these? The error is source size is incorrect. This is incorrect. Oh yes, actually they're right. This is not the length of the buffer. This is clen. Fair, fair. So there we go. Original length 23, compressed length 32. Then what the fuck? We didn't gain a lot, did we? Uh let's crank up the compression level. 20. We didn't gain shit either. I think this stuff is too small for compression to actually do anything useful with it, I think. Yeah. I mean, either that or there's something horribly busted somewhere, but I don't think that's the case. Yeah, I think it's too small to be compressed. But we can try the dictionary approach. So give me a second. I'm gonna refill my teacup, and then we can try the dictionary approach. So here's how I'm gonna do it. I think we're gonna do fruits. So we're gonna have a dictionary of fruits, and then we're gonna have a sentence with some words that are not fruits and some words that are fruits, and hopefully we get some mileage out of the dictionary. We'll see. Okay, I'm back. Do-do-do-do-doom. What are we gonna do next? We're gonna try the dictionary stuff. Does that look like? I forgot. I forgot. Exclusive context, advanced compression API. No. Streaming. Were dictionaries presented before streaming? No, I don't think they did. Streaming. How to. Simple dictionary API. There we go. Compress using dict. Decompress using dict. Okay, dictionary. So for dictionary, we're gonna have the dict. Apple, pear, banana, orange, lemon, I don't know, peach. So this is gonna be our dict. We're gonna use compress using dict. Hmm. This one's a context. Wait a second. It does want a context. I thought it was supposed to be the simple API. So we're gonna need to get our hands on a CCTX compression context. How do you get that? Flow. My editor crashed. No. It was a bunch of work. Uh, mm, Create CCTX. Destination is going to be the C buffer. C buffer length. Source is going to be sentence. Dictionary is going to be dict. Compression level, I don't know, 1. This is going to create a new variable. Okay, you know what? Let's do it like this. Center C buff and debuff can stay in here. But then we do this in one scope. And we do this in another scope. And we do, it's going to be CLAN, our new CLAN. There we go. Same thing. And we need to do decompress using dict. DCTX. DC destination is going to be debuff. Destination capacity is going to be debuff.len. Source is going to be compressed buffer clen. Dictionary is going to be our dictionary. And dictionary size is going to be dict.len. Okay. And with this, we do this last stuff. Also, we should do the check if it's an error. What's the problem with this? Expected. Oh, right. This is not. This is PTR. Okay. Bro, we didn't change shit. Oh, wait, no. There's no fruits in that sentence. Right. Let's put fruits in that sentence. There's banana. We don't have banana in here. We do. Do you need spaces? Do spaces help? They shouldn't. They don't. Oh, we're finally getting some mileage out of this stuff. So original length 60, compressed length 43. With dictionary, we go from 60 to 38. Amazing. Amazing. Well, what can I say? Good. I think this is good. Okay, so what would be the next step? The next step is, can we make a reader-writer interface out of this stuff? And the idea is we make a reader-writer interface, but we also provide a dictionary. Or maybe we just don't bother with that. Just a normal streaming. You know what? Let's try to make just a normal streaming reader and writer and see if that works. So so far we have normal compress and decompress working, dictionary based compress and decompress also working. So the next question is how do we do a reader or a writer? We need to implement one. So we need to make const zstd writer and zstd reader. I know that this needs an interface. Which is going to be of type io writer. io reader. Then we need to see what it is that we need to fulfill this stuff. So vtable are the functions that we need to implement. I guess I'm talking about noodles. I can tell you, so if anybody's interested in some Andrew lore, Andrew suggested these to me as noodles that he really likes that are like precisely super dirt cheap, even cheaper than the Nissin stuff. Let's see, cheap instant noodles. I'm gonna recognize them immediately as we see them. So first of all, this one is offensive. Chapaghetti. I'm as an Italian, I'm personally offended by this name. Do not call your stuff chapaghetti. God damn it. These ones. Indomie. I think these are the ones that he likes. I think there are some minor variations of these ones. So I think the versions that he like has, I don't remember if like 3 or even 5 packets. I think these have a weird number of packets of like flavor stuff in them. And then there's a version that has a lower number. And I remember trying it and not loving it. But again, I don't know. I'm not an instant noodle connoisseur, so your mileage may vary. Is Chapaghetti some Italian noodles? No, it's an Italianized name. I can promise you, I can 1000% promise you, you are not going to be able to commercialize a product called Chapaghetti in Italy successfully. No Italian company would do that. That's like suicide. It's just such a bad name. It's just such a bad name. I mean, to my ears, it sounds horrible. uh, it's actually funny that Japanese rice is just rebranded Italian rice in the EU. Do you have a specific example that you mean? Because I get a type of rice that is like it's meant to be sushi rice, but it's grown in Italy. Like we do make a ton of rice in Italy, so there are some varieties that are like quote unquote Japanese varieties, but that they just grow here. When I say quote unquote Japanese variety, I might be like, it might not be a Japanese variety at all, but it's like a variety that is suitable for Japanese dishes. So, for example, let's see. If I search in Italian Japanese rice, let's see if we see the, well, no, I want products. Let's see this brand here, Yume Nishiki, original Japanese variety. So I guess if you trust this one, yeah, but this is not rebranded. This is not rebranded. This is grown here. Like, it's not rebranded. This is a type of rice that is, I don't know if okay, according to this text here, which maybe you can trust only to some degree, but according to this text, it means that this is a type of plant, of rice plant, that is maybe um originating from Japan, but this is 1 bajillion% grown here. I wish we could see like a picture of the back of the uh bag so that we could see the text better with this one. Oh, this one is brown rice. Yeah, but it has text in it as well. Um okay, what if, okay, I'm gonna do a pro move. Watch me pull off a pro move. So this is my bag of Yume Nishiki, and here at the bottom, this part here, okay, you guys are seeing it flipped on top of everything, but this part here says that this bag has been packaged in Italy. And actually, this is probably from the era where I grew up. I think this is from Vercelli. Let's see, Stroppiana. The place is called Stroppiana. Yeah, Stroppiana in Vercelli. So this is where they grew this rice. This region of Italy, Piemonte, is famous for making rice. So yeah, I think it's just risotto rice. Not exactly. No, this is a different variety. For risotto rice, you normally want something slightly different. So you want arborio. It's slightly different. Well, it's not just arborio. There are also a couple more varieties, but it's not exactly the same rice. Whether you could make risotto with this, I don't know. Maybe I've never tried. But this is not exactly a risotto variety of rice. There we go. A lot further north than I thought it would be. Well, in Italy doesn't only grow stuff in the south. Of course, the south has the nicer climate for growing certain stuff, but rice doesn't need a hot weather. So, yeah, this area here, this is the rice area. I remember when growing up and like, um, let me see if I can find it. When like going down this highway, you would see like rice fields all over the place around it. Well, There you go. Talk about it. Like, I don't know if all of these are rice fields, but I can promise you there's plenty of rice fields in Piemonte. Like a lot of them. So yeah. Okay, maybe let's look at an example of an existing writer. What existing writers implementations do we have? Maybe, you know what, allocating writer could be a good example. Show me allocating writer. So vtable is vtable. So vtable is defined. Okay, I'm not 100% sure I'm following everything right away. So when you init an allocating writer, maybe, you know what, allocating writer might be, it's supposed to be simple. It might be a little bit too weird compared to what I want to do. What other writers? The file ones? Okay. Yeah, so takes IO and buffer. Right, and now I remember. We definitely want to keep around IO and buffer. Actually, do we? In our case, we don't. We want the buffer probably, but we don't want IO because our writer doesn't really do IO. So we want the buffer. And we probably want to keep it around. Then there's init interface. So the interface is initialized based on buffer because understandably they need a pointer to the buffer. I wonder why in the other case, the other one seemed to do static initialization of the allocating writer, even though it was accepting a runtime allocator parameter. Hmm. I think in our case we might be closer to a fixed buffer reader writer type of thing. I don't know. In any case, so there's the buffer for sure. We have no mode. We don't care about that. We don't have different init ways of doing it. Init interface. So this creates the init interface. Init interface. Oh, right. What am I doing? Wait. We don't need a wait. No, we do need a pointer to the buffer. Oh, wait a second. So the interface will have a pointer to this buffer inside of it because the interface keeps the buffer. I guess we want a second buffer because we have a buffer in the interface which collects data that we're being given to write. But then we need a second buffer for holding the compressed data. Do we not? I think we do. See you, Penguin. So the question is, okay, so there is going to be one buffer in the interface to collect writes that we are given, but you can override buffer in drain, but I think you still need a second buffer because you need to read the data. You are compressing while compressing. Hmm. Hmm. In any case, init interface then creates an interface, creates an IO writer where we set vtable to something, buffer to buffer. So maybe we want to do this, maybe we don't, but then we want to do interface equals this. And then vtable equals something. Okay. I guess I need to learn what's in the vtable. What is it that we need to implement? So we need to implement send file and drain. This is it. So drain is take scene of writer interface pointer, which we can use to recover ourselves. We receive the data, we see a splat, and we can observe what we have in the buffer. And what we have in the buffer should be processed first. The rest of this stuff comes afterwards. And then we return how many bytes we consumed. Um, there's probably docs on what that should entail specifically. Maybe look at the CD thing where they are writing to the end of the buffer and just require users to provide max message length for space for compression output to buffer. You mean the in place thing? No, I don't think that one works because that one requires that you put in data at the end of the buffer. Like it requires you that you put the compressed data at the very end. And I don't think we can do that with this setup. Also, that one is definitely not compatible with the concept of streaming, I think. Or maybe, I don't know, there's a way of making it work, but I don't think we can make it work with this setup. I still need to wrap my head around the basics of how to write a writer. So I need to unblock myself. You know what? I'm gonna put this here so that I can access it easily. Also, you know what? We want IOTA writer. Let's go look at IOTA writer. So here we have the docs. So yes, there's drain, send file, flush, and rebase. And there's like default operations for all of these. Okay, let's read the docs. We have to read the docs. Send bytes. Okay, so this is drain. What we were looking at before. Send bytes to the logical sink. A write will only be sent here if it could not fit into buffer or during a flush operation. Buffer zero end is consumed first. Yeah, we start by consuming our buffer. Followed by each slice of data in order. Elements of data may alias each other but may not alias buffer. This function modifies writer end and writer buffer in an implementation defined manner. Data.len must be not non-zero. The last element of data is repeated as necessary so that it's written plot number of times, which may be 0. This function may not be called if the data to be written could have been stored in buffer instead, including when the amount of data to be written is 0 and the buffer capacity is 0. Number of bytes consumed from data is returned excluding bytes from buffer. Number of bytes returned may be 0, which does not indicate the stream end. A subsequent call may return non-zero or signal end of stream via error write failed. Okay, send file we skip. We can default to unimplemented, fine. Flash. The default Flash implementation calls drain repeatedly until end is 0. However, it is legal for implementations to manage end differently. For example, for instance, allocating Flash is a no-op. There may be subsequent calls to drain and send file after a Flash operation. Rebase ensures capacity. What's the default? Default rebase. Ensures capacity more bytes can be buffered without rebasing. The most recent preserved bytes must remain buffered, only called when capacity bytes cannot fit into the newest capacity buffer. Okay, I'm not exactly clear on what this does, but I think we can survive without it. Okay. Okay, first thing that we do, let's look at file writer. First thing that we want to do in here is what this guy was doing, which is recover ourselves. Okay, we grab the STD writer. Then what is our goal here? Our goal is to take all the stuff that was given to us and starting from buffer and feed it to the compression function. As simple as that. And I think that we're going to discover what our next needs are once we write that down. So C dot. Let's take a look again at the streaming interface. I forgot. Oh, also merge this. Okay. Streaming compression, how to? Were there some other streaming compression advanced the compression API? Okay, no. Streaming compression. A C-stream object is required to track streaming operation. Create C-stream and free C-stream to create release resources. C-stream object can reuse multiple times by consecutive compression operations. It's recommended to reuse the thing. Okay, so let's create a C-stream in init then. So in init, We're gonna have, what the fuck is this thing even called? I don't know. CS. Um, pointer to C dot this stream. Init C stream. It wants a ZCS and a compression level. So we need a ZCS. Wait, that's a, the fuck? Create C stream. C stream. So we need the context and the C stream. No, create C stream is void. Wait, what the fuck is going on? It's not init C stream. Okay, we want to create. There we go. Okay, create C stream. Create destroy. No, create free, of course. Okay, now I'm going insane. This is a different type, dude. Oh, they said it. That starting from some fucking version, they are the same thing. Okay, they are the same thing. They are the same thing. Okay. Next. Yeah. And effectively the same object. Continue to distinguish them for compatibility with older versions. Yes. Fine. Um. Okay, so we have this. So we can do C dot. Okay. What's the next step? Use the SCD compress stream 2 with the SCD continue as many times as necessary. Set parameter, load dictionary. Okay. Compress stream 2. Compress stream 2. Oh, you know what? If I use this type, I think I cannot use the other one. Oh, wait. It does resolve to the same fucking type. Okay. Wait. This is an opaque. What? Oh my god. Do you guys see this? You know what we can do? zw.zcs zcs dot. No, ZLS, why are you leaving me on the ground? think that this guy can be used. I think I need to change this type. Wait a second. Where's the thing? Where's the suggestions for this guy? Oh, this is struct underscore, but isn't this struct underscore? Yeah, this is an alias. Come on. This is an opaque. So we can do this. So this should allow me to do. Oh, this doesn't suggest the things that we can do in it. Oh, wait, this is a DCTX. Right. This is a CCTX. And so we can do free on it. Oh, but I see what the problem is. Does this function accept? It does accept it, but as an optional. And by accepting it as an optional, we cannot do the dot stuff. Oh, we're so close. I see. We're so close basically to be able to have methods be automatically generated for us so that we don't need wrapper function. So we don't need to write Zig wrappers. But we're not quite there yet, I think. Okay, in any case, let's change this to the right type. DCTX, free CTX, blah, blah, blah. Compress stream 2. Okay, so this one's, well, they call it CCTX. Okay, let's call it CCTX. Let's use their name. Output. You know what? I want to see all these arguments in one screen. Output, input, and operation. Okay. So I guess the idea is that we start by processing the buffer. Mm. Okay, what is output in this context? Because we see ourselves. What is output? In a file writer, our logical sink is the file. So when we look at file writer, yeah, a file writer, prepositional. So let's see, IO W interface buffered header, W interface buffered. What the fuck is that? Returns the contents not yet drained. Oh, there we go. So that's that's something that we want to call ourselves. Output would be another writer. Yes, that is a good point, right? This is a writer that accepts another writer. So I don't think we need buffer in here. I think we need sync. Yeah, we need our sync. So we need that. And the problem here is that this compressed stream doesn't speak in our interface. It only speaks in arrays. So that means that also this is a struct. What the fuck? Um, so it means that um, we need an internal buffer for this stuff. We need a temporary buffer in here. The problem is that if we do that, so our input is, I need to investigate what this type specifically is, but our input is going to be in the first call buffered. So if buffered.len greater than 0, then we do this call here. And our input is going to be somehow that thing. Let's see how do you make it happen. What's the in buffer? What's the out buffer? Does it say? No. Where are these guys defined? Okay, you know what? Like, what is this stuff? Out buffer? Destination size position. So these guys are a pointer to memory, a size, and a starting position. Oh, and these do get mutated. Oh my god. Because the idea is it consumes some of the input, not all of it. Yes. It consumes some of the input, not all of it. And then it writes to an output buffer up to a point. I'm a little bit worried about this. Does it need all the data that it wrote before? Like, will it look at what it outputted before? I hope it doesn't have to do that. I hope that I can set this always to start at 0 every time I call that function. I think it might be lunchtime for me. Yeah. So let's do it this way. Give me 15 minutes. I'm gonna eat lunch, and then we're gonna continue trying to wrangle this API. So the input part seems perfectly fine to me. It really seems perfectly fine to me. The output part, not so sure. Really not so sure. Okay, I'll be right back. Give me a moment. I'm back. What are people talking about? Oh, I'm sorry. We had so many people watching. Everybody got bored. Yeah, it was share stream for a while. Sorry, but I have to eat. Okay, so output, we don't know. We don't know yet what this is going to be. But we know that input should be this. Also, why is this a pointer to many? Why is it an optional pointer in other contexts, but in this context, it's a pointer to many? Wait, can you actually really pass many? No, you can't. I wonder what makes translate C consider this a singular one, while the other one is plural. Who knows? Hmm. Is the file you are viewing in the cache directory a build system as a result of C import? Yes, correct. Correct indeed. That's how it works. C import creates a Zig file with all the definitions translated, and it's in your build process, and you can go to definition in it if you want. You can also go to definition on the original file. So this is the original C file, and then you can go to definition on the translated thing. You have it all. Okay, so that's how I imagine input should be defined. Is this it? So this is kind of it. We still have to decide the operation. I think the operation here is just continue. And directive, okay, it's just a number. God damn it. So this is going to be continue. Hmm. Okay, what is out in this context though? So in this context, uh, out has to be a temporary buffer that we create here. It necessarily has to be a buffer that we create here, right? There's just no other way. Okay, so we can call this. Okay, so this will consume some of our buffered, which becomes the input, store it into output. Then what we want is basically a while loop, right? While buffer.len is greater than 0, no. While input.size is greater than 0. Actually, maybe this thing tells us directly. So maybe this is more of a while true. While true, we call this. This should, I don't know, do something. And then, and then we'll want to flash this into the writer that we are given. So we'll want to do writer.sing dot write all. Destination 0 dot dot output dot size. So we write it all. Although, wait, this is not necessarily something where we have to write it all. Let me think about it for a second. Yeah, we kind of want to write this as much as we can. Because otherwise we would need to save it. Like this would need to be another buffer that we keep ourselves, but that's what the buffer of the other writer is for. So also need two out buffers. This is in buffer. Yeah. So we do write all. I don't think I'm doing good design, but I'm just not used to this stuff. Uh, so we stop in here until we're done flashing everything. Well, until we're done writing everything to that other writer. That should be a try. What does compress stream to return? Size T. So we need to check if it's an error. We probably want a compression error field. What am I doing? Okay, so we need to do this. And so what's the result? Provides the minimum amount of data remaining to be flashed from internal buffers. Or an error code which can be tested using the STD is error. If return is different than 0, flash is not fully completed, there is still some data left within internal buffers. This is useful for the STD flash, since in this case more flashes are necessary to empty all buffers. For end, return equals 0 means that the frame is completed. After a ZSD end directive, if the internal buffer is not fully flashed, I think the point is that if we plan to swap out input and output because we start doing other stuff, we need to keep looping until we get empty. Also, we need to see how this modifies positions and stuff. So, output pulse must be lower than destination capacity, input pulse must be lower than source size, will be updated. They are guaranteed to remain below their respective limit. And the P must validate a valid directive. Yeah, no shit. Um, Wait, this is an enum. Why cannot this turn into a Zig enum? Did I say wrong? No, where's the enum? We lost the enum. Oh, I know why. C enums cannot be translated to Zig enums, unfortunately. Damn C enums. Hmm. Because in C you can create aliases. Like you can create two different entries in the same enum that have the same value, and that is not allowed in Zig. This has been translated. So the C enum has been translated to a bunch of different variables. In theory, you could say that maybe this translation should be different, and that maybe end directive should become a Zig extern enum, which is compatible with C enums. But C enums have also aliases, which we do not support. So I'm guessing, I don't know for sure, but I'm guessing that the reason why the translation happens like this is because of that reason. I might be wrong. There might be other reasons. The right person to ask this question to would be Veka. Veka in the core team is the one who works on this stuff, and he's the one who knows best, I think, why translate things one way or another. Okay. So what I think we need to do here is say, okay, So here we write everything in output, which means that we can then reset output. So we can say output.pause equals 0, output.size. That one doesn't change, I think. Does it? Should it? Um, I think we need to read more. Yeah, you know what? I haven't read this in a bit, and I need to reread this. This explains everything. Can have enums with the same value. What? This is what you cannot do. This is what is not allowed. You cannot have these and these have the same value. In C, you can do this. In Zig, you cannot do it. Yeah, so when I do long streams, I end up out of API quota on YouTube, and I start losing YouTube chat. There's nothing I can do. Okay, I would say this. Sorry, YouTube people, if you really want to chat, come over to Twitch. I'm sorry. I need to read this. So, use XCD compress stream with eContinue as many times as necessary to consume the input stream. The function will automatically update both position fields in input and output. Okay, so that means that the end thing for us means that so this will bring position closer towards the end, I guess. But what we do in our case, so we don't do this. We don't do up until output size. We do from 0 until output dot pause, and then every time we do this, we reset pause because we can do it. So this is a good idea. So this will keep doing this. So our end condition is when position has reached size in input and result is 0. Something like this. Let's take a look. Something along these lines. Let's see. The function may not consume the entire input, for example, because the buffer is already full. Yes. The color must check if input has been entirely consumed. If not, the color must make some room to receive more compressed data and present again the remaining input data. The std eContinue is guaranteed to make some forward progress when called, but doesn't guarantee maximal forward progress. Yes, this is especially relevant when compressing with multiple threads, whatever. Provides a minimum return, provides a minimum amount of data remaining to be flashed for internal buffers or an error code, which can be tested with ZSTD is error. At any moment, it's possible to flash whatever data may remain stuck within internal buffers using this with eFlash. Yeah, so in the end, we don't really care about, the reality is that at this point, we don't care about the internal buffer stuff. We only care about it being done. Because even if some stuff remains in its internal state, that's fine because we're not going for the flash yet. No hidden state. I mean, no, I think there are other reasons. I don't know all of them though. I think if you were interested, you could probably go find this information in a corresponding proposal, because I think that originally enums were meant to be more compatible with C. So breaking away from that compatibility probably, like, without a doubt, has happened for a reason. But I suspect that you might be able to find it on GitHub if you go looking for it. Okay. So we make sure that we have consumed all input. If we have consumed all input, then we're done. And now we need to do the same for other stuff. So it's almost as if this is a function that we want to call multiple times. Huh. Compress. So what does compress take? ZW. Oh, we have too many things called input. You know what? Let's do it like this. This becomes in. This becomes out. This becomes input. There we go. But so the assertion, so the in the end, it means that input will have been depleted once we exit this. And so more than break, this is just return, I guess, at this point. Oh, yeah, break. So this will have been, input has been depleted, output has been all flushed down, and there might still be internal state. But this is not a problem in the end, because that means only that we need to do the right thing when flashing. So our flash implementation will need to call ZSD flash. I just want to get out of web hell at some point. Hmm. Okay, so with this we have first compress what's in buffer, then compress data one at a time, plus the splat thing. Then for data, try w.compress d, and then there's splat. I think the data, I think that means that we need to deal with the last one in a special manner. Let's go read IOTA writer. What does it say? Is repeated as necessary so that it's written splat number of times, which may be 0. So that means that it's not even guaranteed that we need to do it once. So Yeah, we need to do data from 0 dot dot data dot len minus 1. And then for 0 dot dot splat, data dot len minus 1, try w compress this. Okay, I think this should be it. OBuff needs to go down here. Probably should be configurable, but for now, this is fine. I think we have implemented drain. If everything goes well, now we only need to implement flush. Also, although I did notice one thing, ZSTD also has the concept of end. We do not know where to put end. I guess end needs to be some special finalization that you do with this writer that other writers don't need. Let's see. I have a ZSTD streaming writer that uses ZSTD CLI if you're interested. Hey, Prasnet, they use the ZSTD CLI? Wait, what do you mean? If you have a link, I'll take a look. But the first part I understand. The second part I'm not so sure. Why does it like shell out? Like you call ZSTD from the CLI in your writer implementation? What? Sorry for disturbing you from work. I have a general question. What is your thoughts on going in university, or my skills grow faster if I will work instead? I'm not obligated to go to army, and I might be able to go to any informational university in Russia at the end of the year. Well, good that you're not forced to go to the army. That would probably turbo suck. University versus no university. So the answer is your job, your work might teach you more than university. It has the potential. Most likely, your work will not teach you more than university. Or actually, you know what? I'll take this back. Let me restate this second sentence. I think, generally speaking, I don't know what the situation is in Russia specifically, but generally speaking, there are some jobs that are better than university in a sense, in terms of what you will learn. But there is a much, much, much higher number of jobs that will not teach you as much as university. This is not to say that university will teach you a ton. It's just that there's a ton of bad jobs, without a doubt. So, so the answer is a little bit more complicated. There are definitely, like, can you get into software engineering without going to university? Yes, 100%. But to be successful, especially now that AI is everywhere, you will need to get a level of knowledge that is superior than what university gives you, no matter what. So if you go to university, just doing your classes and doing your homework, not enough. You have to do more. If you do not go to university and instead you go work, you will learn other things, but you will need to learn most of the things that you would have learned in university. You will just have to do it yourself. And then you will also need to excel at the other stuff that is not specific to university. So I think that neither work nor university by itself is enough. You need to do more. It does, and when I say that you need to do more, it's not because you need to do. I'm saying, oh, you just need to do more, no matter what. Just do more. No, the point is that university, usually universities are like software engineering university is not that hard. Math that you do in there, not that hard. Physics, you just do a little bit. Software engineering, you like, again, I cannot speak for every university under the sun. There are universities that would be more demanding of you and universities that would be less demanding on you. But generally speaking, software engineering is not a particularly hard university course. It's not the easiest it's not the easiest either. So there will be people that go to university, try to do computer science, and they will fail because it's too hard for them. Like, they just don't have the required knowledge, they don't have the right attitude, whatever reason. It can happen, but generally speaking, software, like computer science, is not that hard. So that means that you will most likely have free time to learn other stuff. Additionally, chances are that if you get boomer teachers, they will teach you the boomer approach to things. They will actually teach you how to do things the wrong way. So in those cases, your goal will have to be to survive the class, get a passing grade, and immediately forget everything that they tried to teach you. There's plenty of examples of these out there. That said, if you end up working for a consultancy company and all you do is stupid websites, then you're never going to learn anything. And AI is becoming increasingly better at making shit software. So they, why pay you to make shit software when they can pay, well, I guess Sam Altman or somebody like him much less to get shit software. So it's nuanced. Ultimately, what I would say is, I don't know how university works in Russia, but like here, it's usually you do 3 years and then optionally you do 2 more years to get a master's degree. So 3 years to get a bachelor's, and then after that 2 more years to get a master's. My recommendation is, again, generally speaking, I don't know the specifics of your university. I don't know your personal specifics. So what I'm saying might not apply to you as well. But if you go to university, aim for the bachelor's, fuck the master's degree. It's mostly useless. Again, you might learn something, but in terms of like the cost that is associated, and the fact that the cost in terms of money, the cost in terms of time, that it costs you 2 years, and the fact that, and like if you start looking at what is it that piece of paper unlocks that you did not unlock with the BSc, with a bachelor's degree, the difference is minuscule. In my opinion, not worth 2 years of your life. So if you go to university, do the 3 years. Do not do more than that. You can definitely also not do university and be fine. Either way, whether you do university or you don't, you have to wake the fuck up. You have to be self-reliant, and you need to run. You just need to run. It's the only way in this field to learn all that is necessary to have a good time. Otherwise, you're gonna get stuck in a shitty job. You're gonna end up using AI or being replaced by AI. So, or worse, none of that happens, and you just keep working your shitty job until you fucking die. So, try to live a better life than that if you can. I'm currently working in C, not overloading either. But it's even worse than Zig because you can't make the trick of having a struct with default parameters. So you can change them. Well, in Zig, the way you do overloading in Zig is this. I mean, quote unquote overloading is you have, const person. It's a struct, and then it has function talk. And then you have const, I don't know, dog. My genius examples, huh? I'm like an object-oriented book function talk. So my point is, in Zig, the closest thing that resembles overloading is that you give the same method to do the different types, and either you just you just do my var dot, and then you can do talk on both, either statically or via comp time, because you can do that typing at comp time. So here's your Zig overloading. What color team is it? IU Mirage. AYU Mirage. You don't have to write it all caps. Do-do-do-do-doom. Holy shit, you were not joking. You are. Where's the. Oh, you have Drain, which calls Paul. Oh my god, because you're reading it, right, because you're interacting with a child. Oh, but you're not spawning it on demand. You're just keeping it in the background. Okay, this is clever. This is cursed. This is evil. But holy shit. I mean, if it works, it works, I guess. Work will teach you how to do your job. University will teach you how computers work. This is the funny thing. Um, I agree in general, but man, will university also fuck up the how computers work part? Because if your university is teaching you that you need to program using object-oriented programming, it is not teaching you how computers work, because object-oriented programming is absolutely not aligned whatsoever to how computers work, and that will make you write shittier software if object-oriented programming is the only thing that you know. And the problem is that I hope that things have changed in the meantime, but back when I went to university, which is actually not that long ago, it's like what? I think it's not even 20 years. But in any case, when I went to university, the programming class would start with the object-oriented programming. And it was like, they teach you, there are three programming styles, procedural, functional, and object-oriented. That's how it started, which is already a bad start. This is not a good categorization. And then, like, procedural, they say, oh yeah, that's what C does. Next slide. Functional, oh yes, that's what OCaml does. Next slide. Object-oriented, this is what we're gonna do for the rest of the year. And it's like fucking Java. And it's turbo S. So object-oriented programming, for the love of God, sometimes can be fine. But if this is the only type of programming that you know, you're fucked. They ruined you. They ruined your brain. When I switched from higher level programming languages to Zig, I had to go through a OOP detox. I had to unlearn all the knee-jerk reactions to, oh my god, these things are vaguely the same. Boom. Giant inheritance button. So that is a very bad attitude from university. Work will teach you to do your job. University will teach you how computer works, but not how to do your job. Yeah, that is definitely true. I didn't enjoy university one bit, but that was because it was 99 theoretical stuff about system information design from the Stone Age instead of practical stuff about software engineering. Yeah, although some of the old stuff can be clutch when you need it. Who's gonna carry the boats? Having a degree does tend to give you a head start in your work. I don't have one. I had to start from a shitty job to work way up to software engineering. I've seen people. Well, this was not nowadays. You know what? There's one thing that maybe I should take it back. So part of my answer was based on my experience with the software engineering market pre-AI. I can see how post-AI. And by the way, I'm saying post-AI not because I believe that AI is like this thing that has revolutionized software engineering and now everybody should be using AI. No, it's just that in practice, it has fucked up the entire job market. But I think that nowadays, it is harder to get a job starting from a junior position. I've known people, I've worked at a company where some people would come in without a degree. There was one guy who I remember got hired who didn't have a computer science education at all, who used to work at a company in a factory where they were like manufacturing stuff, and he was assigned to basically do spreadsheets. So there was this factory, producing metal pieces. I don't remember where we was. Probably I never learned it, but like they were doing this type of work, and he was working on Excel, and his job was to, put in the formulas in Excel and like do fancy Excel programming. He liked it. He discovered that he really liked that stuff, and he got of all things, a MongoDB certification. So he learned how to use Mongo, which is funny because in hindsight, Mongo is ass. But I guess it makes sense because what he was doing with Excel was, yes, it was some programming, but he was mostly, um, he was tending to a database. Excel was a database. So he got a certification for basically essentially a different kind of database. And from that he got hired as a I don't remember if he started with an internship, but he started definitely from the bottom, and he worked his way up, and relatively fast because he was good at learning how to do this stuff. And I think after a few years, he went to work for a like some kind of French startup doing lower level programming of all things, which is funny. So it's doable. But then again, I would not be surprised at all that what you're saying is becoming more and more true as time goes on, because nowadays, because I guess as time goes on, companies will be less willing to, or rather, as things seem to be going, companies seem to be less willing to have junior openings, and instead they're gonna drop box into a, I don't know, pro enterprise chat GPT subscription or something. It's calling the same function with different parameters. Yeah, I know. My point is that, yeah, I know it's not the same thing. My point is that's as close as you can get. um, well, that's not true. There are probably other approaches that you can take to do overloading, but they're not great. Zig will fight you. Zig doesn't want you to do overloading. My current company does not hire junior. Yeah. Either you get in as a senior hire or you get in via an internship that then gets you to a junior level job, then mid, then senior, but you basically never get hired as a junior unless you were an intern beforehand. Mm-hmm. Okay. I'm gonna go get some tea. And I just need to pour it in my cup. And then we finish reading this and then we finish the implementation. Let's fucking go. Okay. Sure, you know what? I'll be right back. Okay. Do-do-do-do-do. Okay, so we were saying if output size is too small, a single invocation of SDZ flash might not be enough. In which case, some room to receive more data compressed data. Call it again with flash. So you might need to call flash multiple times. Okay, that part is fine. At which point you can change the operation. Okay, it's the end part that I need to understand. Calling ZSDEN instructs to finish a frame. It will perform a flash and write frame epilogue. The epilogue is required for the coders to consider a frame completed. Okay, so it means... Does that mean that we need to call... So that means I think that we need to call end instead of flash. When... I think that what we want in our implementation is that whenever we flash, we also want to end the frame. Okay. So drain is fine, I think. Then we need to do flash. Actually, we can snoop at what this guy does. Give me flash. And return a line error. Error. What? W interface of flash. What? Yeah. Drains all the remaining. Yeah, but okay, there we go. Default flash. Consumes all remaining buffer. The default flash implementation calls drain repeatedly until end is 0. However, it is legal for implementations to manage end differently. For instance, allocating flash. Oh, by the way, we're not changing end. We do need to change end. So the default flash keeps calling drain, which is fine. Okay, I think we're good. I think we don't even need to implement flash then. We don't implement flash. The only thing that we need to make sure here is that after we're done with this, we need to do io w dot end equals 0. Actually, no. Yes. And we were saying we are setting end to 0, right? Yeah, until end is 0. However, it is legal for implementations to manage end differently. Yes. So I think this is all fine. The only thing that we need is a method to end the frame. Oh god, close. On our thing. So pub function init, pub function d init. You can even have these open frame if built-in dot mode equals dot debug. Open frame is of type bool, else void. Uh, 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 Size D. Oh, we don't have size D in C. Interesting. Well, use size. Okay, we were saying, I think we don't need these guys anymore. We were saying that we set the default value, and on the init, we assert the anything with a frame still open. Okay, the anything with a frame still open. Have a good night. Also, if the bug. Then what we need is pub function and frame. Although, now that I think about it, I'm not exactly sure what exactly end frame does. Like, what is a frame in the context of ZSTD precisely? Because they're throwing this term around, frame, as a single ZSTD compressed frame into already allocated ZSTD. Man, I wish I could close this fucking thing here. Please don't make me ask this to the fucking AI. Oh no. I just don't know what's a frame. Well, let's see what Claude has to say, I guess. Oh, thank you. Frames. These are compressed data in one or more frames. Each frame is independent and can be decompressed independently of other frames. The decompressed content of multiple concatenated frames is the concatenation of each frame decompressed content. There are two frame formats defined by Z standard. Thank you. This is very useful. Z standard frames and skippable frames. Z standard frames contain compressed data, while skippable frames contain custom user data. So, but here's my question. Does that mean that if I compress a sentence and I send it, I compress it in streaming mode, and I compress it? You know what? I think we're gonna be able to get an answer right now once as we try it. But my question is, do you need to close the frame for the other side to be able to to start outputting that data, how big should a frame be? So the structure of single Z standard frame is the following: magic number, frame header, data block, more data blocks, content checksum. Why is there a content checksum? I don't want the checksum, man. No checksum. I'm guessing we can configure this and disable the checksum. 4 bytes. I would even argue we can get rid of the magic number. That's also not interesting. So 4 bytes, little Indian, garbage number, Facebook. Good job. This value was selected to be less probable to find at the beginning of some random file. It avoids trivial patterns. Okay, well, whatever. Frame header. Data block. What's a frame header? Frame header descriptor. Window descriptor. Dictionary ID. Frame content size. Okay. Optional checksum. Only if you enable content checksum flag. Cool. Okay, this has answered some stuff. It has not answered though. When should we close a frame? Is it a problem to keep a frame open for too long? We don't know the answer to those questions though. But we can try, I guess. You know what? Maybe we can avoid implementing end frame, see how this works. Although with the current implementation, we're not really flushing as much as we should. Okay, you know what? Let's test this. Also, I have to write the reader side, obviously. So let's go read the other one. Okay, it's the STD reader. So we want this. Also, I think we want interface last. Or even first, I would say. You know what? First. So sync IOTA reader. No, this is not a sync. This is the source. Probably instead of sync, we want to call this destination. No, there's another thing called destination. Let's not confuse it. Okay, source. We want a buffer. I think we want a buffer. Actually, I'm not even sure we're gonna need this here. I'm not gonna keep it. Okay, now we need to learn what's in that interface. um, Number of bytes which have been consumed from buffer. In buffer, before these are buffered bytes. After this is undefined. Okay. Actually, reader is not this complicated, right? Reader only has and, right? Yeah, reader only. Writer only has and. Okay. Okay. So with tables, what do we have? Rebase, default read back. Okay. Discard. There's a default discard. Okay, what does discard do? Consumes bytes from the internally tracked stream position without providing access to them. Default implementation is based on calling stream, borrowing buffer to construct a temporary writer and ignoring the written data. On calling stream, borrowing buffer. Okay. Hello, X2. So stream is the only one that we really have to implement. Writes bytes from the internally tracked logical position to W. Okay. No, wait, this is not okay. What's going on? No, that makes sense. Okay, so reader is us. You know what? I'm starting to think that ourselves, we don't need to have a buffer. We're not really doing anything with it. Unless we discover that we have to do something with it. But I think we don't. You know what? Okay, I'm going to add it back if we need it. For now, no buffer. No buffer. We'll see. And this is what we need to implement. Maybe we will need a buffer after all. We'll see. Okay. So let's go read the docs of decompress. We never really read them, I think. Streaming compression, how to. These buffer sizes are softly recommended. Yeah, which ones? Why are these runtime functions, dude? Okay, streaming decompression how to. Uh, init this stream. Is this also again the CTX? Yeah, so it's the same thing. Perfect. Uh, oh wait, we're using the compressed stream 1. We're not using the compressed stream 2. There's no decompressed stream 2. Bonkers. Okay. So call decompress stream to consume your input. The function will update both position fields. So it will increase input position because it has consumed input. It will increase output position because it will have written in output. This function tries to flush all data decoded immediately, respecting output buffer size. If output pause, blah, 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 the decoder has flashed everything it could. However, when output pause equals output size, it's more difficult to know. Okay, this is the thing that we need to be careful about. um, do. So how is this implemented? Also, this is io.limit, I think. So writer is our sink. We need to get ourselves. So we need to do the field parent pointer cast to get our ZSCD reader. Then um, then here's the problem. We have a source reader from which we want to read some bytes. Oh, you know what it is that I'm doing wrong? I'm not using the higher level APIs. Okay, so for the reader is more obvious, and that was a blind spot when I was writing the writer implementation, but now I'm realizing it. So how do we get bytes out of a reader? One way of doing it would be to copy data out of it, right? We make our own buffer and then we copy data out of it. But we don't want to do that. We want to reference data that is inside of it. So I think we want to basically um, this is more nuanced. Also, this is IOR. So we want to access its internal buffer. And from it, we want to get a pointer to its internal buffer. Then we want to decode that. And as we decode it, we want to write what we decode to IO writer. But doing that will require us to use a buffer. And then we need to respect also limit. Jesus. It is not obvious how to write an optimal reader or writer. I need to get more practice. So so we want to do something like const data. It's going to be io reader dot something like peak this, peak that, peak delimiter exclusive, peak sentinel, peak struct, peak greedy, peak array, peak byte. Peak greedy returns all the next buffered bytes after filling the buffer to ensure it contains at least n bytes. Do we want to do that? Returns the next n bytes from the stream, filling the buffer as necessary. Peak greedy. I don't understand the difference between peak and peak greedy. Pump exactly n bytes from the reader to the writer. Ah, lock a pen. Buffered. Oh, I think buffered is what we want, you know. But what if buffered is empty? So how do you fill the buffer? With fill, of course. Fills the buffer such that it contains at least n bytes without advancing the seek position. Um, okay, I'm trying to understand. Oh, rebase ensures ensures capacity data can be buffered without rebasing. No, I'm kind of curious to look at the implementation that was shared before. Again, I'm kind of curious, how did they do? Wait, drain is compression. Oh no, we're missing the other side. We're missing decompression. Okay, never mind. So this is not going to be a good example. Um, Let me reread the documentation for stream. Implementations are encouraged to utilize a mandatory, making a Discord killer. Well, killer, I don't know. I don't know about killer, but I'm definitely making a Discord for me and people that like me, uh, who would prefer a self-hosted, a self-hostable Discord, open source Discord, one where you can connect from more than one device, even if you're logged in from the same account. One where you don't need to pay $35 per month so that people can stream at 1080p in your server. That's a Discord for people like this. Whether that's a killer or not, I don't know. Probably not. I made one for myself too. Don't tell me you wipe coded it. Yep, of course. So, implementations encourage to utilize mandatory minimum buffer size, although this function is usually called when buffer is empty. Whose buffer is empty? Our buffer is empty? So the idea is that the idea is if we had a buffer. I get it. I get it. So somebody is pulling from us. They're pulling from us, and they do so normally by consuming our buffer. That's how they pull from us. But our buffer is empty, so they want us to get bytes from the other reader. Hello, Karitam. Want to look at it? I'm sorry. I'm not interested in vibe coded projects. Let's see. Although this function is usually called when buffer. I got a spammer. Oh my god. When are we getting off of this shit? I want a Discord that doesn't have spammers. Also, another thing that I hate is that moderation on Discord works kind of the opposite way as it does in Telegram. In Telegram, you delete a message from a spammer and you get the option of banning them. In Discord, you have to ban, and then by banning, you get the option of deleting their messages. Although this function is usually called when buffer is empty, how's the SDD stuff going? I think I've written a function in Writer. I'm now trying to wrap my head around how the reader is supposed to work. Turns out the readers are more complicated than writers. At least, I think. So it's also called when it needs to be filled more due to the API user requesting contiguous memory. In either case, the existing buffer data should be ignored and new data written to W. In either case, the existing buffer data should be ignored and new data written to W. Really? In addition to, or instead of writing to W, The implementation may choose to store data in buffer, modifying seek and end accordingly. Implementations are encouraged to take advantage of this if it simplifies the logic. Okay, I'm not sure I understand what to do now. So, our buffer needs here's what I do know. If we do have a buffer, our buffer needs to contain our buffer needs to contain decoded data. 100%. That's what I do know. I wasn't sure if we needed a buffer, but now I know that to make something functioning, we do need to have a buffer. So buffer it is. Okay, and this buffer does contain decompressed data. So that means that in stream, apparently in stream we can choose whether to put the encrypted data in our buffer or to send it over to W. So let's reread this section. In addition to, or instead of writing to W, the implementation may choose to store data in buffer. So this means that we write to buffer the tail, not the head. Although this function is usually called when buffer is empty, it is also called when it needs to be filled more due to the API user requesting contiguous memory. In either case, so whether it is empty or not, the existing buffer data should be ignored and new data should be written to W. In addition, or instead of writing to W, wait. The implementation may choose to store data in buffer. Okay, so if there is data in buffer, we leave it there. We don't take it out. Makes sense. And then we can either append to it or write to W. But I'm guessing that first we try to append, if it makes sense for us to do so, first we append to the buffer, and then second we write to W. Not the other way around. So, what does that mean for our implementation? I think that for our implementation, first of all, I think since we're talking buffers, with the implementation, I think in our case, we need to answer that buffer is greater than 0. Well, whatever. Okay. Okay, so we do have a buffer. Our goal is to fill our buffer. We don't care about anything else. So where do we get our data? We get our data either from the reader buffer data, or we get it from the reader itself. Well, how does that work? Because if it's buffered, I don't want to copy it. That's my point, I guess. You know what? Give me a second. I'll be right back, and then we continue. Yeah, I think that we need to. I think that it is in our interest to first see if the reader has buffer data. No, I think it's in our interest to have this motherfucker buffer stuff no matter what. Although it could be unbuffered. What do we do is that if that thing is unbuffered? God damn it! I'll be right back. There we go. By the way, there's SED decompress. Uh, Good point. And the buffer needs to be at least these plus block size max. Oh my god. Mm, so okay, thank you for the information, Vesim. Would you say that our Zig implementation is comparable in performance to the official implementation, to the reference implementation? Also, this doesn't change the fact, though, that do we have a reader? Holy shit, we have a reader. Or rather, well, this does wire to readers. It is a reader. Holy shit. I didn't connect the fact that this decompression thing would be a reader. I understood that we had the implementation. I didn't know if we had the actual reader. Okay, let's take a look at how much bullshit we were not going to do that is probably necessary to do a good job. Let's start from stream. Where's stream? This state new frame. Oh god. In frame skipping frame. The Zig implementation was used to fix bugs in the spec. Oh god. That's funny. Um Vesim, can you answer another question then if you're knowledgeable of this stuff? Which by the way, that might also give you an understanding of kind of where I'm at right now. What in the flying fuck is a frame? In this sense. Um I see that so I'm using the streaming compression stuff. So I'm guessing here we're doing the same. Um the question is, um hello crypto code. Do I need to close frames? Like when my plan is to wrap a TCP connection in ZSTD. My question is, can the entire TCP session be one quote unquote big frame, or do I need to um close the frame occasionally? Also, if I put on one end 10 bytes, is it guaranteed that the other side can decode those 10 bytes? Or is that what a frame is? Something that guarantees that if I put like 1 byte and then I close the frame, that 1 byte will be decodable on the other end. Otherwise, risking the fact that until I send more data, that 1 byte will not be, it will not come out of the reader. Okay. I don't know. I don't know about that. Uh, the output buffer is asserted to have capacity for window length plus block size max. output buffer undersize. Okay, so that means that we don't need to make our own reader. So we can, I don't know. Let's scrap the reader plan. We were not doing too well anyway, so might as well scrap the plan. I'm on board with it. This guy only has one problem. You know what? Let's do it like this. Let's do it like this. Temporarily, we're gonna take it out, but we don't want necessarily to flush from rain. So maybe we want to have our own call to flush. So maybe we want to implement flush. Let me think about it for a second. Hmm. Now let's implement flush. Okay, while we're here, just implement flush and let's see where that leads us. So writer, what's the signature of flush? Be easier. Oh, it's like just itself. Okay, and it defaults to default flush, which is pub, which is also what we want. So flush. Actually, this can return an error. First, we call default flush. Oh, we can even do IO default flush. And then it's just a safety feature to mark the last frame. Okay, but yeah, it's the continue end stuff that I'm talking about. Yes. To mark the last frame, no. I think you mean the last block. I believe that I might be wrong, but my understanding is that a frame is what you end when you do end. That closes the frame. So until you do end, you haven't closed the frame. What a frame is, I don't fucking know. Maybe it's something that resets. You know what? Maybe it's something that resets the some compression heuristic. I don't know. It probably has a meaning, but I just don't know what it is. My question though is, I'm worried. So here's what happens. I'm worried that I send, for example, from the server a message, and the client doesn't receive the message, or rather doesn't receive it fully. Some fucking byte remains stuck somewhere, and then it's gonna be unable to decode the message until the server sends another message, and that would fuck up all communication. So default flush. So first we do default flush, and then we do this. Result is ZS decompress stream 2. But in this case, input has size 0. There is no input. Hopefully we can put null in there. Output. Yeah, we do want to have an output. We want to have an output buffer. So we keep the output buffer. Can those be null by any chance? What happens if you pass null for one of the 2 pointers? Sorry, we're going back to compression. Nah, they just don't say shit. Man, I hate these people. Okay. Where's my music? Why did we go to this? What happened to my relaxing piano? No. Okay. So in is gonna be that. Like out can also go horizontal. I don't see why not. Out is gonna be that. And then we're gonna do this. While true, call this. Oh, we need ZW in here. Get our hands on ZW. Turn right failed. And then next is if result is different than 0, well, is equal 0, break. It has squeak. Okay. So this is just for flushing. We don't do continue. We do flush. So this guarantees that we flush as we should be flushing. If this doesn't work, then we can do end, I guess. I don't know. We're almost done because if result is 0, or or rather, every loop that we go in here, we are writing this to the sync. So we're doing zw dot sync dot write all buff from 0 to out dot pause, and then out dot pause equals 0. Okay, hopefully this flush makes sense. I guess we'll see. Okay, time to do surgery. Time to do weird surgery. So we're gonna use one implementation of the writer against the Zig implementation of the reader, and we'll see how that goes. So yeah, we're doing surgery on a grape. Okay, so we have our sentence. Then the next thing that we want to do is make a writer. Although we're gonna use, so which base writer are we gonna use? We're gonna use an allocating writer. So AW So the STD wants a buffer. Actually, we have cbuff, right? We have cbuff and debuff. We can use them. So, access type, I know the writer, and what did I get? Okay, no, we're good. Okay, so that's the. Oh no, we're not good. What's the problem? Const. Oh fuck. Okay, var. Sorry. Then this also needs to be var. So this is our writer. Okay. Then we do w dot write all sentence w dot flash. Then if they succeeded, we do actually here's what we do. defer std log dot r. So we print the error if there's one. Log info. Type void found right failed. Yeah. Okay, so we look at the compressed data. Then we do var uh zr, I guess. Base k. There we go. So once okay, so decompress wants a reader. And a buffer and some options. Okay. So the reader is hello 11. So we need a reader that reads the written data in the allocating writer. So var, is it a buffer reader? I don't know. io.reader dot, come on, give me something good. Fixed. There we go. Do you usually stream on weekends? I do, yes. Not all the time, but I do. So this is our fixed reader. So it's actually a FR fixed reader. And I think, yeah, this is a straight up reader. So we want to do just this one, FR. And then, what is it that we wanted in here? A buffer, debuff, and some options. No idea what's in the options. Let's go figure it out. Verify checksum false. Yes, I like that. DSCD default window length. Holy shit. Default window length, it's big. These are big boys. These are big boys. Well, we'll see what happens afterwards. Any plan for Federation? Yes, we absolutely have plans. We're not going to do it. The only form of Federation that we're going to have is RSS, in the sense that you can create channels that publish on RSS, and you can create channels that pull from RSS. That's it. I don't think the Federation has anything interesting to offer other than a bunch of headaches. But you know what? Even though I do have this position and I'm, how can I say, like I have matured an opinion after thinking about it for a while, I'm happy to discuss it. So like, if you think there might be something interesting, let's talk about it. That said, I don't look at Federation as something interesting. I look at it as something mostly problematic. And then if for some reason, in some circumstances, you can get more value out of Federation than the annoyances that it introduces, awesome. But in the case of Awebo, I don't see much to gain. I only see all the annoyance. So, um, mhm. Yeah, thank you. I'll definitely keep that in mind once I start trying for something more than just a small sentence. ZR, it's our const R equals ampersand ZR dot reader. Okay, we have a reader that we can read from. Mm, now, how do we print this, what comes from the reader, and be happy about it? I guess we can read 1 byte at a time. We print it, and then we call it a day. I mean, it makes sense that we don't know where to stop, because once you have a reader, usually you have the protocol that tells you when it's a good time to read. What we can do is put a 0 byte in here. How do you put a 0 in here? Well, here's the 0. So we put a 0 in here, and what we can do is trim until delimiter, and we use the 0. Actually, it doesn't even have to be this. Like, it could very well be just a semicolon. We just put a semicolon in here, and we say trim until delimiter semicolon. That being said, doing trim until delimiter semicolon might end up not printing anything, and maybe going byte by byte. So let's do it like this. While true, r dot read take byte. We take a byte, and we sd dot log dot info. And we print the letter, I guess. Man. Local constant shadows declaration of C. All right. Hello, Matt. How am I? I'll let you know in a second because we're gonna run this bad boy, and depending on how it breaks, I'll be able to tell you how I feel. Actually, what does this look like to you? Oh, show me this error. Why is this okay? Oh, the colors. That is nice. Okay. What is the problem? No formatting slice. We are printing something and we think that it has a formatter, but it doesn't. Oh, here. Why did I think that this? Oh yeah, no, that makes sense because we want to do std.zig.fmt string. Use X, but if I use X, it's not gonna show me when the same string is repeated. You know, if you use this, you will see ASCII text as ASCII text, and you can see your own string being repeated in the compressed message. That was funny to see when I was testing this originally. Okay, next problem. Expected IT found optional, or else I don't know. Oh. Actually, we don't even know if this can fail. This might very well not be able to fail. You know what? Catch unreachable. YOLO. Oh, it's not catch unreachable, or else unreachable. Oh wait, dot question mark. What am I doing? It probably can. It depends. I think this might be. Um, I think this is just a struct. I might be wrong though. No, I think you're right. It might be something that they allocate. Ah, there we go. Catch panicum. I mean, or else. Okay, what's the problem with drain? Does not support struct initialization. Oh, like this? Yeah. Expect type U8 found end of stream read failed U8. Oh, we didn't. We need to try some stuff. This needs to be tried. Expected type alien flag found const U8. Yeah. Oh wait. Yeah, the PTR. Okay. Next problem. Wait, what? No matter return types returns implicitly. Oh right. So drain. I think the answer is all the lengths. So this is probably a very bad implementation of writer, but this drain goes all the way to the end. It doesn't accept partial stuff. Yeah, you're right. I forgot that I think I even have it. Yeah, I have a call to free. So I forgot. But yeah, we do have a call to free. Um, so I think the answer here is um computing the length of these guys. I'm guessing they also need to be multiplied by splat if there's splat. So okay. Yeah. Um so okay, I think we're good. I think it's time to see where we go. Okay, so dictionary stuff is fine. Actually, let me put a separator. So we did dictionary, and then this is stream like reader writer. So let's put a stream separator. Okay, let's see what happens in stream. So compressed data, blah, reach unreachable code right away. We're not doing great. So write all sentence. Also, out of curiosity, what if we omit flush for a moment? Does that change anything? No, we still have nothing written in compressed data. To be fair, yeah, this is definitely a problem in here. So we do writer, which is our writer. Okay, let's see if drawing gets called. Writer called with nothing. Writer called with nothing. Everything else in the buffer. Okay. Yeah, but I would like to see an error. So if this guy has issues, that is fine. But I would like to see an error. So we get buffer. Buffer line is greater than 0 for sure. We end up calling compress. Compress makes this stuff. Okay. Like I would like to see an error, but it doesn't even show me the error. Okay, let's make giant buffers. I don't know. That didn't change anything. I think I'm fucking something up. I'm calling sync write all. Let's std log.info Writing to sync these many bytes. There's no point in the contents. We don't care. Eh. Writing to sync 0 bytes. Writing to sync 0 bytes. Hmm. Pause should out pause should not be 0 once we return from this guy without an error. Am I using this the is error like wrong? No, I believe it. I believe I'm not wrong. Actually, you know what? Let me double check because I've written it before above. Yeah, different than 0. Different than 0 means error. Um, I think this might be too much. I think we're segfaulting now. No, we're not segfaulting. Yeah, no, we are segfaulting. This is too big. Um, I think it's returning the number of written bytes and not updating the out buffer struct. But it should. The docs say that they do update the out buffer. Compress stream 2 in here. Output pause must be lower than DST capacity. Input pause must be lower than source size. Where are those values even defined? This is talking about variables that don't even exist. I mean, I think they're talking about this is not updated. Oh my god. Yeah. Output pause and input pause will be updated. They are guaranteed to remain below the respective limit. Yeah, it's buffering the data internally. Yeah. That would make sense. But then that would make sense. But we were calling flush at some point. I think I commented it out. No, I decommented it. I uncommented it. Oh fuck. Here's the problem, I think. Wait. I forgot to wire in flash. I implemented our own flash and then I forgot to wire it in. Fuck. Error union is ignored. Yeah. It was kind of weird that there were no programming errors in this function, right? It's because it wasn't used. There we go. So, right, with stuff, result 0, write into sync 0 bytes, result 0, write into sync 0 bytes. Compress data. Okay, so we get to the flash. The flash actually does the flashing. You can see that the message has some of it we stays the same. The double hello got slightly compressed. The banana ram stays. Holy shit, wait. Then the double bananas disappear, but apparently somehow they will be placed back. And then there's a bunch of peaches that have disappeared. Okay. And then we reach unreachable code. Respectable. I would say respectable. Hey, Loris, we spoke briefly in Amsterdam about Andrew and you speaking at a conference. How best should I contact you for following up? An email address, perhaps? Yes. You can send me an email here. Send it at loris at ziglang.org. And I'll relay this information to Andrew also as well, of course. Next error is due to the buffer size passed to the compressor. Could be. Is that it? Yeah, we failed the size check. So we succeeded, although it seems that the compressor can make do with a tiny buffer though. So this can stay small if we want. Oh, you know also what I noticed? Maybe I should have increased these. What if I increase this one? No, it still likes to keep the data inside. Okay. So the decompressor, huh? It's still this motherfucker. Okay. Yeah. Wait, the fuck am I doing? Just see buff. Okay. And then hello, banana, ram, banana, 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 banana. Read failed. That's because we hit end of stream. Can you not get end of stream from Take Byte? Yeah, why are we getting read failed? Who's read failing? Wait, why do I see this if the error is this? Who's doing this? Oh, I think I get it. No, I don't. No, I do. I think I do. Um, I imagine that the ZSTD reader wants to see a frame end to consider it an actual end of stream. I think that I think the problem here is that we are getting an end of stream, but the internal state of the decoder is one such that it hasn't seen a frame end, and so it's suspicious about what happened. I still don't understand why this. Let's see, reading frame. I'm confused. But if we are in new frame, in frame, skipping frame, does it ever return end of stream? It does in this case. Not inside of a frame. Nothing buffered. Then that's an actual end of stream. On return end of stream, there are exactly 0 bytes remaining on the frame magic. Any potential magic bytes should be considered failure. Okay, so the problem is that we are not closing the frame, and so this reader doesn't like reaching the end of frame. Well, sorry, the end of stream without seeing an end of frame first. Choices. Um. Okay. I mean, we succeeded. We have a writer and we have a reader. I suspect that the reader is slightly better than the writer. I think our writer is kind of like the jankiest possible kind of writer that you can write. In this case, but what can you do? So here are the downsides of not using the C implementation. I believe that the Zig implementation doesn't support dictionaries. So that means that we cannot play around with dictionaries. Let me double check my assumption. But yeah, well, it doesn't have an option for this, but dictionary deflag. Or maybe not. Maybe it works. But wait, no, it cannot work because this stuff cannot work because you would need to be able to pass in the dictionary in any case. So in any case, the init of this guy should allow you to pass in a dictionary. So the fact that we cannot do that, setting at an error, you're literally staring at an error that says that it's unsupported. Oh, was I at an error? No, well, no. Okay, it's um maybe you're right, but a dictionary ID thing, it's not exactly supporting dictionaries. So I don't know. Maybe it's a different thing. You probably means what you think it means, but dictionary IDs are different than dictionaries. I was reading in the C implementation, like in the C header file. Sorry. So there are some things going on with dictionary IDs that I'm not sure exactly what that is. So cannot play with that, but can be used. Yeah. Mm, now, do I want to wire this to Awebo right away? I don't think so. I think this was a good exploration, and I think we should at some point wire this stuff to Awebo. But I think we can wait. I think that ZSD compression is probably not a bad idea to like. I think we should add all at once compression and TLS. Ideally, compression inside, TLS on the outside. Um, but until then, I think there is no point in complicating what's happening over the wire. But this was a good exercise. And also, I'm not throwing away the code. The code could be useful. I do think, though, that the writer, I think that my writer sucks. But I'm not, it's not immediately clear to me how to write a better writer. Hmm. Okay. Let's start playing with client persistence now. So, good adventure. Wait, flow terminated with illegal instruction. Malloc heap correction detected. Wow. Hmm. Yeah, it has to be something external. Yeah, it has to be something um where you end it yourself. The way that I would do it personally, well, you know what? I don't understand all the implications, but one way of doing it could be that you basically end a frame every time you flush. So every time flush is called, you end the frame. But but you know what? I think there's something sus going on. Oh no, there isn't. The problem was that I was using a fixed reader. So the fixed reader contained all the bytes that we compressed, and then it returned end of stream whenever you try to read past that. Yeah. I think in any normal operation this is fine. It would be nice if they explained a little bit in the docs what is a frame, when how big should a frame be, when it's a good time to end a frame in order to start another, yeah, and that kind of stuff. Hmm. Okay. So I think that what we want to do is um Maybe we should commit this stuff so that we can merge Andrew's branch. We can try it out. Although Andrew's branch has already been merged. You know what? Here's what we can do instead. Git pull. Warning, redirecting to blah, blah, blah. There is no tracking information for the current branch. Oh, git switch main. Good. Okay. Remove Awebo DB. Create a server. Okay. Server run. I think the client database is going to be busted. I forgot to reset it. Yeah. Contact site authorizing. Setting name ready. Load state and begin connecting to hosts. I think our Pulse audio is not offering any audio interface. Do we have audio enabled? Yes. So here's the question. Why is this not suggesting anything? I think that Andrew was saying we did merge his PR, did we not? Yeah, we did. More progress on Pulse audio. So there should be this. Oh, no, you know what? This is working on our Prince devices before panicking. Okay. Wait, that's how it goes. We go into settings, and this makes it panic. But before it panics, we see the devices. Yeah, there we go. Check it out. Sync device. ALSA output, PCI, blah, 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 analog stereo description, HD audio controller, analog stereo sample rate, 48K, format S32LE. Channels 2. And then source, two sources, HD audio controller, analog stereo. Oh, monitor of the fuck. What? Okay. And then HD audio controller, analog stereo. What? What? It's the same thing. Also, source and sync. So wait. So they just have shitty names, I guess. And here's the server. And then we hit a panic to do. Well, we have something. It's used for recording audio of syncs. Oh, okay. I see. So these are I get it. These are like my speakers, and these are my speakers, but you can record them. Understood. Makes sense. So we have something. We are like nature is healing. Well, the audio backends are healing. bit by bit. Cool. I'm not gonna pull these on Mac because there's gonna be conflicts probably, and also, I mean, it's not useful on Mac. Doesn't do anything. So what are we doing here? Let me show what the current state is and what success looks like. So state is that we go in core. We look at the host sync function, and here's what we're gonna do. Here we're gonna print log.debug host sync data, and we print the entire host sync. Also, why is this getting host sync? Not by pointer. Okay. Okay, let's give it a format function. Mm-mm-mm-mm. Yeah, this is gonna be complicated. So we want to do this host sync, open parentheses. Then we want user ID. A host sync contains a user ID. Yes. Active ID, and then we need to print information about all the things that we send. So, for example, um, well, name, I guess. Okay. Then we want to print, I think, the IDs of the users present in this list. So for hs users dot items, you actually let's do u.id user ID, and then write all this. So this is users, and then we need to do the same with channels. Mm, okay. All right. I think I'm just gonna copy these. Yeah, we don't need to add this thing. Okay, so this is how it works. And then the final one is gonna be actually just this. There you go. Okay, this is a relatively detailed overview of what's in a host sync. Let's add update UID. So does channel have it? It doesn't. Okay, user needs to have update UID, which is a U64. This is also U64. Server host sync. Yeah. So it needs to be like this. Actually, keep calling it like this. Oh, sync. Yeah, a channel doesn't have um update UID. Let's give it to it. Where are we right now? Channels. We're trying to create a new channel based on what? You create um channels. This is server only. Chat counter column channel ID equals 5, and then we do +1. Oh my god. Holy hard-coded numbers. So in here, we need to be given a good unique ID for this guy. Oh my god. Chat counter. Really? Oh my god. Okay, let me think how this should work for real. The way this should work for real is that we've given also both a channel ID. Oh, we're checking here if the name is taken. I think we need to be given a pointer to host. I guess we can recover it. Opposite way. Oh, oh shit. Okay. So this create channel thing was never wired into the new stuff that also accounts for the existence of the database. So this whole function is kind of jank because it doesn't understand that there's a database. What it should do is, I guess, do the channel insert in the database and use that to know what the channel ID should be. Just let the channel, let the database decide at this point because we don't care. And but we do care about the update UID. So no chat, not this, no this. Um, Although you know what, we could put a panic in here. We could do it through panic. This stuff in any case is not. This stuff in any case is not wired in. So let's fix first stuff that we do have wired in. Hosting expected 3 arguments found 2. Right. Dude. Okay. Expected T found const T. Host GP delta const hosting. What? Wait. What? What are you smoking? Expected type T found const pointer const T. Oh wait, I'm taking a pointer too many times. Is that it? I'm taking a pointer too many times. That's what it is. Okay, so in theory we build, and now we should see in the client the host sync data that we get. Let's see how far we go. Run server. Run client. Where's my Delta boy? Oh, check it out. Hosting. User ID 1. Max UID 0. That's already wrong. Name banana. Yes. Users Delta 1. So it's a Delta update. There is one user which has ID 1. Okay. UID 0. Not okay. Channels. Delta 3. One has UID 2. One has UID 3. One has UID 4. That's fine. So these guys are fine. And then there's another line. All right, it's fine. Okay. So, what is my point? My point is that what we want to achieve is that if we close this now and we reopen it and nothing has changed in the server, we want this host sink to be empty. We want it to contain no users, no channels, because we have those already in the server. And then we want to do the thing where we modify one user, and modifying one user means that the client gets an update only for that user. I mean, we only have one right now, but we can do the same also for channels. That also requires us to implement editing correctly for these resources in the CLI, because I think in the CLI right now we do not update their update ID, and we need to do that. Oh, this is gonna be fun. This is gonna be fun. Okay, so give me a second. I'll be right back. And then we're gonna do this work. So we need, first of all, to make sure that we wire in this data correctly, we pass it around correctly. And then after that, we need to start doing some math in the server that we're currently not doing. I'll be right back. I'm back. Rejoice. So, how do we make this work? First of all, host needs to be self-aware of its own um, maximum UID. So, um, we go in server run and we start questioning our approach to state initialization. We do select the latest UID, but what do we do with this information? We put it in state.id, init, right? Because we have these ID generator thing. So this is fine. This is fine, but also not. This is fine because it allows you to do next easily. That's fine. Did we give max UID to host? We fucking did. What if we did not? So does this cause programming errors? It does. Because in compute delta, we do it this way. And we should just not do it. So we, instead of this, we do max UID. Oh, but I see what the problem is. I see what the problem is in this case. The problem is that this is the user max UID, which is not what we want to send back. We want to use these for filtering. I think we want straight up the ID generator, but we don't want to generate new IDs. Server max UID. So it this way. And let's rename this to server max UID. Okay, so that means that now oh, but with this nice. So this needs to be client.maxUID. That's an ID generator. New and last ID. Do we really run this well? Do we really Zig build? We do Zig build. Okay. So this is better. Run the server. Run the client. Let's see what we sent over. User ID 1, server max UID 12. That is indeed good. Success. Name banana. Users. Blah, blah, blah. Channels. Okay. Now what we need to see next is from the server perspective, we need some logging for when we're computing the delta. So in host, when we compute the delta, we say log.debug, computing delta for user something, max UID something. There's no log. Why did we break? User max UID. Happy now? I think we're happy now. Although we need to start the server first. Okay, show me how these went. Computing delta for user 1, max UID 36. Now here's the funny thing. 36 is a suspicious number. A client should not have a max UID greater than the greatest ID generated from the server. There's something suspicious going on. Yeah, 36 is a weird number. So what happened there? I don't know. Me no sabe. Let's do this. Well, we broke something. Okay, we definitely read some garbage data. Although we should know about this because we just added a new field that I think we're not in core. That is not in core. That is in, is it host that does that? Host does sync. Hmm. No, it's not in here. It's in persistence, obviously. In persistence. So the problem is when we do load host, what happens? we're selecting name, but we're not selecting the greatest number. This stuff is, it's a bit still all over the place, but that's fine, I guess. Here's what we can do. H dot, hey, thank you for the 21 subs, Zig. Thank you. So H dot client, no, you know what? Since we're touching all the client stuff up here, I'm gonna do it here. Client dot MaxUID is QS dot select MaxUID run db no arguments dot question mark dot get MaxUID. Okay, this should do something. Although I don't think that that was what's causing the crash. It was what was causing the crash. Surprising, but okay. Please. Loading host 1 MaxUID 0. That is actually, I think, fair. Oh, this guy crashed? We did crash. Okay, let's try again. So, it is fair for us to think that the host has nothing when we load it for the first time because we have nothing. Now, close this, reopen it. Now we should load it with max 12. Almost there. Not quite, but almost there. Max UID is 3 for some reason. Why is it just 3? It's supposed to be 12. I mean, yes, 3 is for channels, but what about messages? Oh, you know what's happening? We're not storing messages in the client. That has to be it. We can figure this out. It's SQLite 3, and then this delicious thingy here. Database is locked. Oh, yes. Empty. Well, that explains it. So the client is not recording messages. I was hoping it would, but it's not. Also, in the server, are we seeing? Yeah, now we are seeing that the user tells us that the max UID they know of is 3. So it seems that they don't know about these messages, but they should know about these messages. It's just that they don't. That sucks. Okay. Why are we not saving messages in the client? Because in host sync, we're doing some things good and some things wrong. Host sync happens in here. So this function is doing some things right, some things wrong. Channels. Oh yeah, I mean, definitely. We're doing upsert of channel. Where's upsert message? Well, messages. That there it is. It's on us. You're welcome. I love your content. Well, thank you. Those are very kind words. Um, so how do we do this? We upsert all messages, I guess, one by one. It sucks, but we can do that. And then we need to delete the ones that are too old after that. So it's super ugly, but QS, so for new ch dot name privacy update UID, the init format shall the init sync kind. Oh, right. It depends on the kind. So, right. We had code for this. I think I nuked it. So we switch on new ch.kind. And if it's chat, we do something. If it's voice, we do nothing. If it's chat, we do for chat dot messages dot slices, and then for the message. Okay, now we have all messages, and we do qs dot upsert. We don't have upsert message, so gotta come up with upsert message. Yeah, we're gonna upsert message. Okay, so where is upsert message? I think I'm putting them in common queries, even though they are not really common. But yeah, we need upsert message. Oh my god, what joy! Just like we got to do upsert channel, now we get to do upsert message. Insert into so us upsert message. Messages. Table. Where's messages? Okay. Unique ID. Origin. Created. Update UID. Channel author. Body reactions. Okay, values are hmm, 8 values. Okay, what can conflict? Oof. UID can conflict. So these can conflict, and update UID can conflict. I think these are the only two that can conflict. Horrible query. Could be worse though. Uh, message ID. That's UID. Origin. U64. Created. U64. Update UID. Channel. Channel ID. Author. Why does our debugger report errors by tinting the entire window so I can't read half of it? Because it's flexing on applications that cannot tint the entire window. Turning every pixel into red at the speed of light. It's the red debugger. They actually typed the name. Reactions, I guess. I can even leave it null by default for now. I think this is fine. Okay, so we have this. Okay, let's see what we got wrong. There's no created. Okay. There's no update UID. Well, we do need that. Sorry. So might as well add also the rest. Channel. Channel is not a message, but we have this information. Okay, where are we? We are loading from disk. Select channel messages. Okay, so we're in the server. And we're creating a new message. ID is stateid.new. Yes. We might want to save this. Oh, I fucked up some definitions because shit. This is optional for message update UID. This is optional, and upsert message needs also to know that this is optional. Unsupported type. Deserialize unlock inner. What? You don't support an optional number? Don't tell me we don't support optionals, period. Shit. I think we don't support optionals. So our network protocol, I've implemented all the metaprogramming for a bunch of things, just not optionals. Well, what do you know? Okay. So we see, if we see an optional, maybe we put this below enum, since enum seems pretty straightforward. For optional, we do present equals r.take byte. If present is 0, return null. Actually, let's do this. Switch present 0, return null. 1, return. We need to call, we need to recurse. Do we never call into ourselves? Yes, we do. Okay. Serialize inner. Oh, now it's the other side. Yeah. So Optional. So we want to write the value element, which is optional. So we want to do if element is null. We want to just write 0. Else. Yeah. Else we want to recurse. Actually, we don't even need this. Oh, that's interesting. We don't even need this. There you go. Yeah. Keep it like this. Missing start field created. Okay, where are we right now? We're in server run. Somebody's asking to send a message. We are agreeing. Perfect. So we copy this ID. Then we should call it UID. No, fuck. Update. Oh my god. Right. What am I doing? Update UID is now. Okay. So we seem to be building. Let's see what happens now. We fail. Because our query sucks. Second on conflict clause does not match any primary key or unique constraints. Well, about that, the way this should work is that we have in messages, create unique index messages by update UID on messages channel. There you go. Where update UID is different than null. So this is a partial index with a unique constraint. So we're gonna need to reset our databases. And rebuild server run. Yeah, let's try again. Second on conflict clause does not match a primary key or unique constraint. But the fact that this is on messages, update UID, where update UID is different than null. So you're saying that this index so technically it is true, maybe that we can't conflict. Okay, you know what? Fine. Okay. max UID 8. Server max UID 8. Okay, we're in business. So we're in business. We are in business. We are telling the server what our max UID is. We are loading these bad boys on disk. So let's add 1, 2, and 3 as well. Close. Start again. They're in there. What's the new max thing? 11. Server max UID is 11. We agree on that. Now, what we want is to omit from the update everything up to 11, which is literally, since this client is the one that made all those changes, like literally the client should reconnect and have an empty delta update. So let's go do that. This is in host. In host where you compute the delta. And now we need to be smarter than this. So, and we're going to need to use GPA. And we're going to need to do stuff. I'm starting to think that compute delta shouldn't even be in here, but whatever. Okay, so what's the story here? Well, this part is standard. We keep it as is. Users. We don't want all users in here. We only want users that have a UID greater than what the user has seen. So delta users is a std.array list of type user empty delta channels empty. There we go. Okay, so for host users dot items values, if you dot update UID is greater than user max ID. Actually, you know what? If it's lower or equal, continue. Otherwise, try. Oh, we have the thing where we're unfallible. Let's become a fallible function. Try delta users dot append I'm thinking this should be a pointer. There's no reason to copy the entire user. What's in user? Is there much stuff to copy? I think it's not a bad idea to make it a pointer. Let's see if we can make it work. Then delta channels, it's pretty much the same thing. Channel, if the channel of the UID is greater than delta channels dot append the channel. Expected type T found constant, yeah. Okay. Now here's the last thing. Channels we cannot channels we have to copy. We have to copy the channel because we want to fuck around with this copy of the channel because we want to filter out messages from it that are older. So we want to do so the channels are going to be in a messed up state, but we can still filter them out, right? How will that work? Okay, you know what? Let's do this for now, and then let's worry about messages later. Let's at least get this stuff going. Oh, don't tell me that I cannot do pointers. Yeah, it probably wants me to do. Oh wait, that is a different error. Wait a second. Let me reintroduce the pointer. Okay, so users now is going to be this, and items is going to be post.users.items. No. Delta users. Delta channels.items. Okay. Okay, you know what? No pointers for now. Just for simplicity. Just so we can make progress. Okay, what's the next problem? No serialized unlock on hosting. Wait, what are you talking about? Yes, there is a serialized unlock on this guy. Missing try. Oh, man, I wish the flow would stop like losing this information. This one has a try. This needs a try. Yeah, yeah. Thank you. Okay, okay. Let's see what we got. Max UAD 11, Max UAD 11, banana users empty. We're not sending users. We're not sending channels because this client has it all. Because this client has it all. So now here's what I'm gonna do. I'm going to go in, what was it? I'm gonna go in here. I'm going to copy this state. We're going to poop ourselves. No. Dude, you were doing so well. Why are you pooping? No. No. Why are you pooping? It poop. No, don't poop. Don't poop. Don't poop. It poop. Well, How the fuck do we test this? Okay, first of all, we need to make this work also. We need to make this work also when you reopen the stuff on disk, because that's silly. So what is it that's making it poop itself? Because oh, I know what the problem is. Because previously we were mindlessly replacing the old stuff with the new one, and now that cannot be done anymore like this. So in host sync, replace the old name with a new name. Fine. Um, for each user in the thing, add it and replace it. Awesome. For channels, for each channel, call channel sync, place it, blah blah blah. Good. Wait, so what is going on? Is it in core that we do dumb stuff? Host the sync and then commit. Oh, we're not doing anything crazy. So what is the problem? Hmm. Yeah, this is not happening. So what's the problem? I thought we were mindlessly replacing the old stuff with the new stuff, but we're not doing that anymore. Also, the types don't match anymore. They would match previously, so you could do that, but now you can't do that anymore at all. So what is happening? What is happening? Well, things that we can do are take a look at the database. Database seems fine. Bring a stack copy of the user, but that would cause a crash. We're not even crashing. Like the application runs, it's just that it doesn't show content. Our database is locked because we're using it. Can you unlock? Yeah, I don't know. In any case. So it loads stuff from disk. It loads channels, done loading state from disk. Notifying core we connected successfully. And then we get host sync data with nothing in it. Now here's the question: what if we regress the server and now the server sends again everything all at once, every single time? So if we go in host and we change these filtering thing, um, so we hard code it to 0 again, and now the server should do full syncs every single time, no matter what. Will this now work? The server crashes. What did I do wrong? Oh no. Dude, please. No. I'm serializing there is borked. No, it's protocol.zig. Yeah, I'm dumb. This is element. So this needs to be like this. Okay, that's on me. The delta calculation on server side most likely needs some rate limiting to protect against DDoS. Yes, although it's based on only recent data, like it doesn't look through all messages, for example. It only looks across recent. Well, the message part I haven't implemented yet, but it will only look across recent messages, and you only get there after you've authenticated. And yeah, there is a rate limiting system. We just need to make sure that we properly give we give a correct weight to, like, a correct cost to this operation. Okay, so if we do this, oh, then we almost work again. Attempt to use null value. Each user get auto ID. Author ID. Hello, Penguin. So, so we're doing better when it comes to the server sending a full sync, but it's still wrong. We're still doing some dumb UB somewhere. Hmm. 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 I think this can be made nicer. I think we can do it like this. Yeah. There. So what are we fucking up? Um. Hmm. I mean, it's clearly something dumb that we do here. This host is a pointer. This get gives you a pointer, so that is fine. So I think the problem is doing users set is good, not doing user set is bad, but also we do users get. So if users is garbage, then we are already doing UB. So I guess what we need to do is see what happens, see how shaped, what's the state of host after persistence. What happens to host after persistence? So init host db will call load host on the host, and then we'll set certain things inside client. Load host will do this. Wait, am I going insane? This is wait, this guy lives in this scope. He's not getting out of it. Wait a second. What the fuck is going on in here? So we're um okay, setting aside the weirdo metaprogramming that we could get rid of. But so we're setting this on the server, the live pool. We're loading disk on this from disk, and we're setting it here. This is never reaching the host. This is somehow never reaching the host. This is also never reaching the host. Well, I think we got our answer, don't we? Okay, let's simplify this garbage. So first of all, load host is now an actual function. Then it doesn't have to return like an implementation or anything. Then what are they by default? They're that. Does this host have any kind of default initialization that is half decent? Yeah, I think this should be fine. So this shouldn't need this. And it's just h.users. And that's it. Okay, try localhost. So there we go. I think that now we're happy. Yeah. Oh man, that code was busted when I terribly busted. Let's unbreak the server. So let's fix the server to do the right thing. That's in here. No more foo. There we go. Now this makes much more sense. Perfect. Perfect. Okay, now here's what we're gonna do. Finally. Remove Awebo copy. Remove Awebo GUI. That's also old. So what we're gonna do here is copy Awebo to Awebo copy. Run the client. Add a message. Close it. Well, we reopen it just to double check. Our message is still there. Close it. Now remove Awebo and move Awebo copy to Awebo. So now we have an out-of-date database. Now we are lagging behind. Let's see what happens. Oh, I know what's happening. That's wrong. Oh shit! I know what's happening. That's wrong. What's happening that's wrong is that the channel metadata has not updated, but its messages have. Right. Right. We need something different for channels. We cannot have a channel that has messages in it. We need to deal with messages separately. So this is my fault. But you know what? As a temporary test, let's bump up the channel and see what happens. So we are killing the server. We are going in Awebo, select start from channels, and then update channels, set update UID to, oh god, what was the maximum value for this stuff? 12. Set it to 13. Where ID equals 1. So now we have forced an update on this guy, rerun the server, last ID generated 13, yeah. And now our sync contains one channel, the channel that was updated. So this is correct. And now we see our new message. The problem is we are placing messages under channel updates, and that is not good. We need a different type. We need the concept also of a channel delta in a sense, and that only contains metadata. And then we need messages. We need one thing, like one slice of messages that just contains messages that have either an ID greater than our max UID or a update UID. Well, but the second thing is just for the future in case that once we start implementing message editing. Okay, this was nice. Like trying this stuff for real in person is what's allowing me to understand. I don't know where my imagination imagined wrong. So next step is channel delta. Sorry, host sync must contain channel deltas or like channel syncs. That's what we need to send down, and then we need to send messages in separately. Yeah. Honestly, sending messages separately is not a bad idea. I think it fits. Okay. So this is not ready to be committed yet. We're making progress, but we obviously need to fix this mistake here. So we need to do the message stuff that I was describing, and then after that, I think we can commit these new changes because at that point, we'll be good. And I think at that point, this feature can kind of be dropped there. Are end-to-end encrypted private messages planned? Yes and no. We are not going to work on private messages uh, anytime soon. It's going to be the thing that we leave for last. I'm a believer that it is a bad idea to use self-hosted servers to hold private messages. And I also think that it's a bad idea to do peer-to-peer. So in my opinion, there should be a different system. I would be interested in exploring that, but I think it would have to be a centralized system. So the idea is you can use Awebo without signing up for anything. It's just like a self-hosted server, clients, you connect to your self-hosted server, you're good. But if you want private messages, then optionally, like completely as a completely optional thing, you can sign up for this centralized system that is entirely dedicated to doing DMs, which could be end-to-end encrypted, maybe. I don't have a strong opinion either way. Like, I understand the value of having end-to-end encryption. I understand the value of privacy. But I think there's also like annoyance in managing a system like this. Let me put it this way. I think that we should have end-to-end encrypted chat systems. I don't think that every single chat system out there should be end-to-end encrypted. I think it's fine to have both. So, or also, I would say, if we had almost no end-to-end encrypted chat message, then I would be a lot more interested in having this. But we have some of these. So, in any case, long story short, that to me is kind of like a completely separate system from servers. So, my goal is to get servers running and good and be like make servers good. And then in a future, maybe where servers are super good, then we could talk about DMs. But it's not a priority. um, yeah. So I think I'm gonna stop here. This has been a 8 hours and 36 minutes long stream. We have done a lot of stuff. We have looked at ZSTD. We have implemented most of the synchronization stuff. I learned something new. I learned that the way I was thinking this could play out needs to be tweaked slightly. I mean, to be clear, we could modify this. We could change this to say the channel is included if it has a update UID that is greater than, or if any of its messages is like that. That also would work actually. We don't need necessarily to have one unified messages thing. So either way, we can make it work. We'll see. Thanks to found DVUI. Yeah, DVUI is awesome. You know what? What I do with DVUI looks bad, but you can make stuff look good with DVUI. Check out Pixie by Foxney. So Pixie is a pixel art editor, and it looks good. It even has animations. Can you imagine? This is DVUI. What you're seeing here is DVUI. So you can make good looking stuff. Okay. So let's see, what are we doing? Is there anybody doing Zig? I don't see any Zig. No Zig streaming. You know what? I think I'm gonna be lazy. I'm gonna be lazy. So thank you all for hanging out, and I will see you next time. So